7, 6, 5, 4, 3, 2, 1.
You'll never have the sacred stone.
Oh, this you crazy mother.
What's going on, everybody? How's everybody doing tonight? I'm gonna have Marc on here in a couple minutes. I'm gonna call him up. Let me see if I can pull this trick off real quick and see what we have. Let's find out.
Hello?
Do we have the man with us?
Yes, we do.
Ladies and gentlemen, on with us right now is Paul, the wizard behind the curtain. We figured we let him jump on real quick and say hi to everybody since he really doesn't get a chance to very much. So, what's going on, brother?
Well, not too much. Just thought I would take a minute to jump in the chat, but I guess jumping on the Skype is a little better.
Yeah. Yeah. Well, everybody was anxious for you to jump on and want to actually have the time to do so. And we had planned on doing it with Bill a while ago, but that Bill has been kind of not streaming much lately. So I figured we'd get you on here. And
Well, Keith, it may not look like it, but when I'm on, I don't sit down at all.
yeah.
I'm running back and forth, adjusting stuff.
And there he goes. I knew we were going to press our luck with all the computer usage on his end. So it wouldn't surprise me. Well, the stream's still on, so I think we're good. But yeah, we tried. Oh wait, he's back on now. Should I try him again? Let's see. I don't want to make him drop the stream though. I don't want it to be hold on, let me see if I can get him again. I'll try it. Let's try it again.
Okay.
Is a computer yeah, it's a computer
Well, it's the bandwidth, guys. I apologize. I use all my bandwidth for the stream. So bandwidth is at a premium here where I stream from.
right.
So to give you the best picture, I really have to shut off all my computers, anything Wi-Fi, and just stream. That's it.
Right. So, ladies and
So
gentlemen, that is Paul, and I don't want to ruin your bandwidth, but I will say you will be seeing a lot more of him, especially coming up in the next couple weeks. We'll be up in New York. We'll be up there hanging out with Marc and Bill and the gang and everything for Pine Bush. Anything you want to say to the chat while you're on, Paul?
No. I just I did see someone compliment me on my alignment tonight. This Celestron mount is very good when it's polar aligned correctly. That is true.
Yeah,
But they're very temperamental. So one night it could be perfect, and the next minute you're out there every 2 minutes adjusting it. So
that's how it goes.
it's a spin of the wheel, but we'll take it when we can get it. So everybody enjoy the stream, and let's hope the air settles down, and hopefully Marc will be on soon.
Yeah, Marc will be on in the next couple minutes. Paul, I thank you for coming on with us and sacrificing some bandwidth for a couple minutes. And we're definitely going to be hearing more from you in the future streams. So thanks for joining me, bud.
No worries. All right, guys.
Yep,
Yes,
take care.
sir. Okay.
Bye-bye. We got mic number 1, and we should have mic number 2. Do we got you?
Yep. I'm still here.
Yep. Looks like everything's registering on the
Richter scale?
Yep. Everything's good. Say hello to the chat. I'm just going to let people ask questions from chat and see what kind of stuff we get into, if you're feeling up to it.
Yeah, I'm okay with it. What's interesting, I was looking at the stream earlier, and I noticed the crater Gassendi that Paul had focused on.
Right.
And Gassendi is very prominent. It has that very nice central peak with a long shadow right now. It's really, really pretty. And that was very nice.
We were just on it actually a couple minutes ago, and people were asking about it, like, what is that? So, I mean, if you want to explain the difference between complex craters and regular?
Yeah, I mean, simple craters are what they sound like. They just look like holes, little round holes in the ground. And complex craters, and it depends on the size of the meteor that's hitting the moon, all right, or anywhere. Actually, you can have complex craters in any solid body in the solar system, and we can have simple craters in the same way. And on the moon, a complex crater is created by a large meteor, and when it hits the moon, it causes these massive shock waves, and the massive shock waves cause a huge amount of material to be pushed out from the center, of course, as the thing hits. And then sometimes, on its way out, the shock waves wane, and you get these rings that, and usually the rings appear about halfway through the diameter of that crater. And those are a complex crater with rings. Now, you also get, at the edges of the craters, you can get these terraces where it looks like a stepped terrain down to the crater floor. And that's also part of the complex crater development. But, when you look at the moon, you also see, besides craters with these big peaks in the middle and rings and terraced walls, sometimes you get craters like we see here, where the crater, is a flat bottom crater. And, no craters are made with a flat bottom. This is an evolution. This is what happens after they hit. Sometimes that's caused by material coming back in lesser majority of the cases. But in most of the majority of the cases, it's actually from material filling it in later. That material could be molten material from when the meteor hit the moon and made molten material come welling up from the interior, floods the interior, and of course it finds its own level. And thus you get a flat bottom crater. It could also be from another meteor hitting the moon and then basically sending up a massive debris cloud, which then comes down and settles in the crater and causes a relatively flat bottom. That can happen as well. And that's not as common as the magmatic, the lava intrusion into the craters causing that.
What is the other crater that everybody says they see a big gun in? Is it Pythagoras, maybe? I think that we show sometimes it looks like it has a giant gun in the center of it.
Yeah, actually, I did that for one of the shows. Actually, they asked me to look at that, and basically, if you look at Gassendi, I mean, depending on how you rotate Gassendi around, and you're say a still image, it looks like it could either be like a gigantic Death Star weapon, or a gun of some sort. I mean, those are just illusions, and because the bottom line is, if you think about it, there's really no reason for an advanced race to have a giant gun.
Well, and especially with the size of that Pythagoras is, that gun has to be miles, large.
Yeah.
I mean, it's absolutely huge. But it does. Pareidolia is a really big thing.
Yeah,
and that's the only thing that we really have to go on. Is basically our brain making images of stuff that we already know and trying to make sense out of it. But.
Yeah, right. Exactly right. And that's why we have a man in the moon. The man in the moon was created that way, with that very type of thinking. Right. So, but still, it's interesting when you look at it. Oh, here's Gassendi again. Actually, is my voice like 20 seconds behind?
No, you're good. I mean, on this anyway, as long as you have your YouTube muted, because you would be like 20 to 30 seconds behind on
Oh,
YouTube.
okay, all right. Okay, that's why I don't want to refer to a crater because I know it's going to then go away.
And actually, Arnie brought up a good point last night. And this is a crater spot that I've been watching for a while, and I totally forgot to look up the area of it. But it looks like there's a perfect arc inside of another crater where smaller craters go from large to small, like almost perfect, step down. And I forget what it was called.
Well, that could just be that could be subsidence of the underground from a lava tube. And when they collapse, sometimes they make pits, and they look like craters, but they're actually subsidence pits where the lava tube is collapsed underneath progressively over time.
Right.
And so they end up looking like a neat little string of craters when in fact they're just collapsed ceilings of these lava tubes under the moon.
It really grabbed my attention because they were in like a perfect arc.
Yep.
And they were going from big and almost perfect proportion stepping down. The same amount of proportion every time stepping down to the smallest one. It really blew my mind. I was like, wow. And I'm not sure, once again, I'm not sure if that was, collapsing lava tubes or not. But it just, and we'll probably see it sometime tonight. It'll pop up on the screen. But I want to remind the chat, too, if anybody got any questions for Marc. Marc, are you looking at the chat?
I am, yeah.
Okay.
I am, yeah.
So he'll see your questions on there if you want to, and we're going to take questions about anything. So whatever you want to ask. If you want to ask about aliens, you want to ask about extraterrestrial life, you want to ask about planets, stars, nebula, sun, whatever. It's all open game tonight. And I should also point out that Marc is not an alien debunker.
No, I'm not.
Let's get that out of the way right now. He's not here to totally, debunk everything that you say because he's had experiences himself.
Yeah, I'm a science guy, and these things don't happen to me until they do. You know what I mean? And then it's like, well, how do I explain what happened? I can't.
Right.
And to that end, my mind has to remain open. Of course, I get videos every day. As you know, I'm the Mutual UFO Network's chief photo and video analyst, and so I see these things all the time. And many times they are just misidentified ordinary objects. And I try to be gentle with people, so I don't make them sound like they're being idiots, because they're not. They simply have genuine questions, and I think it's fair to answer them with a genuine answer. It's like, and sometimes they accept that, and sometimes they have already made up their minds to what they want it to be, even if it's not what it is.
Right.
All right, in my opinion, and so we agree to disagree. It's like, well, okay, but I'm telling you what I've seen over time. And like, when I did that Aliens on the Moon show, I saw somebody writing about it yesterday, and you and I were talking about it privately. And the Aliens on the Moon, they wanted me to make the outcome a certain thing, and I couldn't do it, and I wouldn't do it.
Right.
Because you only get one chance to get your reputation properly, instilled in someone's mind.
And with a lot of these shows, it's all about sensationalism, and getting the most, views and the most people watching, kind of like it is with YouTube, where you have all the UFO channels that are, really not reputable, but, they still get the views because they want, they want the clicks and everything like that. Now, some of them try to be reputable, and most likely, most of the channels that you find that are reputable UFO channels and alien channels, they don't have a lot of subscribers because they don't put out videos every single day or 2 a day. They put them out when they find something interesting and that they can explain through reasoning. So just remember that if you go to smaller YouTube channels for UFOs, they're most likely the ones that are doing the real investigative work.
Yeah, that's right. And I guess in the grand scheme of things, it's sort of boring to be doing ordinary UFO work, right?
Yep.
Yeah, that's just the way it is.
No glory in that.
Well, I don't know though. I mean, you have a good time with it. I have a good time with it.
Yeah.
We just went by.
Speaking of,
Bianchini there.
Did you watch that video I sent you?
Oh yeah, with the object coming in front of the moon.
Yeah.
Yeah, I mean, the unfortunate thing is,
it was right when
it
zoom
couldn't have been timed more imperfectly.
Yeah,
but it was
that's what Paul said. He's like, I zoomed it right at the wrong time. It was like it's coming out right then.
Yeah, I said when I watched it, I went, Paul, you did exactly the wrong thing, and I laughed because I realized he didn't see it. Nobody catch these things until later, and that's fine. Yeah. But I said, like, you did it exactly wrong. It's exactly at the wrong time, because as soon as it was entering the field of view, all of a sudden it zooms and you only get a small portion of it. Right. But it was I did still do some still frames. It did not appear to be a bird flying through the field like we saw tonight. Earlier tonight there was a bird that flew through, and someone asked, was it a bat? And I don't think it was, because the wing beat rate of a bat is very, very different from what we saw. Bats have a more of a staccato, sharp wing beat pattern, so they'd be like, flap, 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 because they're changing direction constantly, because they're actually not flying just for fun.
Right.
They're flying because they're on the prowl, on the hunt. And if they're flying towards something, especially at some kind of speed, then they're making course corrections all along the way. I mean, bats are extremely hard to follow, for instance, with a camera. I've tried to do that. I've tried to follow bats with a camera. And it's like, wow. You got to be on wide angle to catch them, because they flit all over the place. They're extremely good at it. And what flew through the field here was a regular wing beat, and it went, from the lower right to the upper right or so. And it
probably a
that
seagull.
Well, it was a regular bird. It seemed like a smaller bird. Maybe it was a duck. I don't know, but it wasn't.
I'll tell
a
you
bat,
what, Mitch got a question in chat. I've seen this come up a couple times from him, so I might as well address it now. And he puts on here, why is Jupiter's rings tilted, as in the entire planet? Is that because of Nibiru?
Well, the answer is no. It's not because of Nibiru. Okay, you have to understand that there's a number of interactions that occur when there's a moon orbiting another planet like that. Jupiter has 60 moons, and among them are the Galilean moons near the middle. Right near the outside of the planet, the closest ones to the planet, the 4, and then the rings are outside that. Well,
you know what? I think I know what he's talking about, because he just posted in the chat, and he's asking why they were one way and all of a sudden they were horizontal. Mitch, that's because Paul actually puts it that way. He actually turns the camera in the
like he's doing
in the
now.
telescope, like he's doing now that you see on the screen with the moon, to actually make it for better viewing. So that's why you see the lines and the rings turned on Jupiter different ways, because he's just turning the camera inside the telescope. That's all.
And Mitch doesn't mean rings; he means bands, right?
Yeah,
Cloud bands.
Yeah.
Okay.
That's where we got confused.
Yeah, because the rings on Jupiter can really only be seen with a backlit situation. But like with telescopes here on Earth, we can never see the rings because they're not backlit. Mm-hmm. In any way from here, we're always seeing them. The sun's coming from behind our heads, basically, and going toward the.
But you wouldn't be able to catch them even with a long exposure.
I think it depends, because they're black. Mm-hmm. So it depends if you can catch them in contrast to something else, and that's the kind of thing that like a Hubble might be able to do. But I don't think that a regular backyard. In fact, I'm pretty sure I know a backyard telescope can't do it. They can't see the Jupiterian ring, the Jovian rings that way. But that's Jupiter's ring system is, well, as you know, we didn't always know it was there. We only discovered it some years ago when one of the probes went through there, and we saw it backlit, and that's how we knew it was there. Saturn's rings, on the other hand, those are massive, rings that all add up to a small planetoid, a small moon. Right. If you put them all together. I don't know. I think it's pretty cool. And the moon's gone, by the way. It blew up. It's just gone.
Yeah,
there's the nuclear blast.
Paul was on the ball tonight. When I talked to him earlier, he was really excited because he's like, man, it's clear down here. It's for the most part, it has been. You got a little bit of humidity distortion in the air down there, but besides that, sure. It's actually a really good night down there.
It looks nice, actually.
Yeah.
It's very nice.
Yeah. You were talking about telescopes earlier. And you were talking about the largest ones here on Earth. Now, you said the one that's already in function is the one in Chile, is it?
No, it's in Gran Canaria, in the Canary Islands.
Okay. Now they are building the one in England, of course, right? The super jumbo large or whatever kind of stupid name it was. The super jumbo large telescope.
Well, there's also There's also the Large Synoptic Survey Satellite, the LSST, and that's going to be a new ground-based telescope that's going to, see first light soon if it hasn't already. I'm not sure what the progress is on that, but that's going to be a big telescope as well. And that's going to be, I believe, down in Chile, and it's going to be allowing us to see, into space in a way that is unlike the Hale telescope, which was the Palomar telescope, formerly the largest telescope. And the Keck telescope on Mauna Kea, I mean, that's the third largest.
Right.
Okay, but that one that you're talking about isn't even in the top three. I mean, the second one, the second largest one, is a product of the USA and in Germany, and it's at McDonald Observatory down in Texas, and that's the Hobby Eberle.
Well, how many meter scope is that?
That's 10. That's a 10 meter.
Wasn't the one over in England, the extraordinary large telescope, is going to be like 30 meters or something?
I think. I mean,
it's going to be absolutely. Supposedly, it's going to be the biggest one that's going to come around for a while.
Yeah. Now that 30-meter telescope that you're talking about, that's actually going to do infrared studies as well.
Right.
But I think that's going to be. I'm not sure where that's going to actually be set up. But everybody in the world is like, on top of this and want this thing to happen. And but Mauna Kea in the United States is where that's going to go. I mean, that's the preferred site for this thing. So there's no place in England actually that is high enough.
Well, it's the UK somewhere. I'm not sure exactly. I just saw that they had the site prepped and ready to go. But either way, I know we got some big telescopes coming in, and of course with the James Webb going up in a year.
Yeah.
I guess it is once a 2 years.
It'll be next year, and the Webb telescope is going to, primarily be an infrared instrument. It's not going to be doing like visual science. It's going to be doing infrared science, and we want that. So
we can hear all the skeptics going, "Oh, that's a composite image. It's not real." Blah blah blah.
Yeah, because it doesn't look like a photo I'm used to seeing.
Yeah.
Well, the truth with that, Keith, is that I think you know this, and that is that when you look at these infrared images, they don't tell the ordinary person what they want to know.
Right.
Okay, but they tell the scientists, okay, what they want to see, what they want to know. And, when we look at the infrared data, that's something that's going to, for instance, be able to tell us that we're seeing water vapor in this planet's atmosphere. We're seeing oxygen in this planet's atmosphere. Yeah. We're getting infrared signatures that are only visible with this certain type of chemical constituent in the atmosphere. So the James Webb Telescope really is an odd-looking bird anyway, and it has this big. Basically, most of the quote-unquote telescope is actually a shield that prevents the sun from shining on the actual mirrors.
But it's going to be absolutely awesome, the information that it gives us to be able to piece together. I mean, it's just, I'm so excited. Like, that's the one thing I'm so excited about is this Webb telescope. Because not only that, because everything has to be perfect in order to get it where it needs to go and get it done right. It's just so much stuff has to go right. You have to be perfect one time.
Yeah, and it's going to be parked at that Lagrange point, which is a point where the gravity from all the combined forces of the gravity from the combined pulls of all the planets is sort of canceled out, so to speak. And this, but I'm saying obviously for everybody in the chat so they understand that the telescope goes to a place where the gravitational pulls are absolutely minimal from all the planets because the combination of all of them together make this little null zone, which is there's one between the Earth and the Moon, for instance, and you can see this one in your head, in your mind. When a spaceship goes to the Moon, there's a point along the trajectory where the pull from the Earth is equal to the pull from the Moon, and it's not being pulled any more to the Moon than it is to the Earth at that point, and that's that null zone. That's that Lagrange point, they're called. And there's many of those points, and there's some odd ones based on the orbits of the planets and the sun, where like 60 degrees ahead of the Earth's orbit and 60 degrees behind the Earth's orbit, there's another pair of Lagrange points where these asteroids are just hanging out there. Yeah. Asteroids that made their way into the inner solar system but are captured at this Lagrange point and just sort of stay in there, kind of bobbling around.
And I'll tell you what, I don't want to get lost in the chat, so I want to just run through some questions that are popping up in here real quick. And the first one is from Home Universe. And it says, "Hi, guys, I have a question. How do astronomers know so much about the planet's cores and compositions and layers under the surface?"
Well, there's a lot of things that tell us about that. For instance, when we look at a planet's mass, we understand how planets are made, and it's something called differentiation, which means when the planet is a molten blob forming, the heaviest elements basically go to the center, and the lighter elements stay near the outside. Right, the heaviest elements sink toward the center because of the gravity of that mass. Now, depending on the mass of the planet, we can figure out its density, and based on its density, we can guess what it's made of. Now, many times we can examine the surface of the planet, and the surface can give us clues as to what's in the interior, because chemicals on the surface have been at times thrust upward from underneath the surface, and so we see clues about what the inner structure of Mars looks like versus the inner structure of, say, the Moon. Now, and that's actually a very good question, because these interiors will also determine, for instance, what the surface gravity, the pull due to its own gravity, is for that particular moon or planet, and it will also determine, for instance, there's Kepler's third law has to do with the periods of the planets related to the radii of their orbits, and that has a relationship to the mass, in that a planet of a certain mass will be captured in an orbit and have to go a certain speed to maintain that orbit. Right. Now, the orbits, all right, will not be particularly determined by the mass, but the orbits will be determined by the speed at which they're moving through space. And they then have these moments of inertia if they're rotating, and if we can calculate their moments of inertia, that is their resistance to being rotated in a sense, then we can figure out something about their mass and what they're made of. If they're really, really resistant to motion, for instance, then they're probably iron. Because most of the elements that are in a lot of planets are iron and nickel and in the cores, and except for like Jupiter, which is like a liquid metallic hydrogen, which the concept of metallic hydrogen makes people's heads explode. It's like, what does that mean? It just means that it's hydrogen under great pressure, and it's like a liquid hydrogen. And so you're subject to the chemist's definition of what metals are in the periodic table. So I mean, there's a lot of science we can do. We can actually do seismic pulses when we're on a planet, like we've done on the Moon, and depending on how fast those pulses return to us, that tells us a lot about the composition. And in fact, we can figure out what the Moon is made of at various depths in the Moon. So and
there you go.
Yeah, I mean, that's pretty much it.
All right, here's a good question for you. When are we going to stop faking space?
As soon as Earth becomes round.
Yeah, that. And a follow-up question: how do we know the Earth is round? Do we even want to get into this, or do we want to save this for A-hole astronomy? Because
because see, in A-hole astronomy, we can say it like we want to say it. Here, I'm very polite to people, and even when they say, for instance, and this wasn't necessarily a bad question actually, but when people say something that's totally stupid, and as I said, not this question but was asked, but I try to see it from their perspective, because to them it's not stupid. To them, they think there's some meaning to it, and I would address it. And I'd like to.
Here's the thing: I don't even think flat earthers believe the Earth is flat. I think most of them just do it just to be contrary and get it's just like it's whatever the norm is, automatically go against it. So the flat
just
earthers,
for the controversy,
right? The flat earthers are the same people that believe in all the conspiracy theories, and they follow along the same path and you can point them out, and most conspiracy theorists tend along the same lines as others. So I don't know. Yeah, we won't get into the flat Earth thing because it's just I just think it's ridiculous. Yeah,
we'll save that
for A-hole astronomy. But
Jimbo and Deirdre said that something flew by, so we'll have to go back and look.
Cool. There should be a timestamp, somebody in the chat, so we can mark that down and check it out. Yeah.
And then Satinderjit 4 asked what causes gravity, and I think I talked about that earlier, but that's okay. Gravity is actually, this is the odd thing. Gravity is a force that we know how to calculate. Okay, F equals gmm over r squared. Or g is the gravitational constant, m is the mass of the say the planet, and little m is the mass of the moon, and r squared is the radius between them. And that force due to gravity, the force between these two objects, that's a calculable thing. We can calculate it. But the question is, what causes that? Well, guess what? We only know that objects with mass have gravity. We don't actually know what gravity is, although we have clues. And you know this, Keith. When we saw these black holes that were colliding far out in space, we actually saw these ripples around them. And those ripples were actually gravity waves. Now, gravity waves were predicted by Einstein, and we saw them in this collision of these black holes. Now, it's actually a merger. These two black holes are colliding and merging. That must be an exciting place. Not. I don't want to go anywhere near that. But when this merger was occurring, there were ripples sent out, like ripples in a pond, but they were caused by the massive gravity of these black holes. And this was the first time, this was like 2016, the first time we actually saw gravity waves. And that could mean that what comes next is gravitons, or gravity particles. Just like we know light is dual nature. It's a wave and it's a particle, right? It has photons and it has light waves. We say it acts like it can be treated as if it has a dual nature. Gravity could be the same. And if that's the case, if we can see, quote unquote, or detect gravitons, it means that we can probably at some point reflect them. And of course, that's anti-gravity, isn't it? And that's kind of where I see us going.
And just for reference, these when we detected these gravitational waves this year, they were at two different points on Earth. I think one was like in Arkansas or something like that, and the other
in Louisiana, and then one was up in Washington State.
Right, and they both detected it at different points in. I'm not exactly up on the science about how it actually worked. I probably don't want to get into it because we'd be here forever. But no, that's the day last year that all the scientists were really happy that they finally, actually measured it for the first time and confirmed it. And it's just by the slightest shift in the reading. So,
and that was with the instrument was called LIGO, LIGO, the Laser Interferometry Gravitational Wave Observatory. Really, but there's one, the Haverford, Washington, and I forget where in Louisiana, but the two of them detected it simultaneously. You're exactly right, and that was really cool.
Right. The you know what I wanted to ask you, satellites. We have a lot of people that come in that say satellites aren't real. We had a couple in here tonight. Now, my explanation: how many satellites are in space, roughly? Do you think?
Well, do I think or do I know?
Well, you think, because obviously there's some classified ones, just a ballpark figure.
Sure. I mean, ballpark figure, there's around 11,000 active. And inactive satellites, if you want to count dropped bolts off the ISS and space shuttle throughout the years, there's more than 1 million pieces of space junk up there.
Easily.
No lie.
Now, people always ask, why don't we ever see them on the moon stream? And the point that I try to make to them when I try to explain it to them is, we do sometimes, but they're wondering if there's that many, why aren't they coming across all the time? Now, number one, some of them are so small you can't see them. But if you're talking about active satellites, you got to remember that you can go outside right now with a straw and look up at the moon, and you can see the entire moon through the straw.
That's a very good point. That's a good analogy. You're heading down.
There's a small area of space that you're looking at, and I don't think people really know how big the Earth is compared to our point of view of the moon.
That's right.
And even if we had 10,000 large satellites around, you would rarely ever see them because you're looking so small of an area. What are your thoughts on it?
My thoughts are exactly what you're about to say, which is probably the right thing, and that is that when you look at the sky, all right, and you look at the moon, you're looking at such a small piece of the overall sky that the chances of seeing anything go through the frame are really slim, and that's because satellites, depending on where the moon is, there's east-west moving satellites, and that's what you may see going through. You have a better chance of seeing those than the north-south ones, because the north-south ones have all these lines of longitude, from east to west to go through, over the North Pole and South Pole, North Pole, South Pole. But east-west, they're kind of all around the equator. And if that's where they are, well, then you have a better chance of seeing all those. But the trouble is that even though there's that many, the moon isn't crossing our equator all the time, is it? Okay, the moon isn't always on the equator. It's not a perfect orbit. It's got a slight inclination. There's a orbital wobble with the moon very clearly that is visible over time. So, and it has to do with whether that small ellipse the moon is making around our planet is sort of on the incline one way or the other. Mm. And so there's no guarantee you're going to see a satellite at all. The fact that we do is actually kind of miraculous, to be honest. Yeah.
And if you want to, I mean, there is a way, and it would happen even around you, no matter where you are on Earth. If you wanted to, you could actually track the ISS and get a good pair of binoculars, on a clear night, and you'll be able to go out there and watch the ISS cross right above your head if you want to.
That's right.
I've been trying to map it out and path it where Paul is, where one night I would love the ISS to come right across the face of the moon. That would be, yeah. I can't wait for that to happen. I've been tracking it down and trying to, map it out when it's actually going to happen. And we can do it. And that's something actually I think I'm going to try to get you in on when we come up there in a couple weeks.
All right.
And
sure.
we'll go to and we'll jump on all the programs and see if we can find a time where from Miami we'll get the ISS crossing the moon at just the right. It might. Hopefully, it's not for 15 years or something like that, because that would suck. But you never know.
Well, you know what? The telescope and a lot of people know that I actually set up this observatory here, and it's called the John Zach Memorial Observatory, and John was a guy that was going to do this automated observatory project with me, right. But sadly he died from cancer, and that was about 4 years ago. So the telescope sat in a box for 4 years, and finally I decided to just act on it, and I did it, and I got an observatory building with a dome,
and it looks great, by the way. Looks real good. I cannot wait to get in that thing.
Yeah. Well, you'll be in it in a couple weeks.
Yeah.
Rain or shine. And the bottom line was that that entire building, once I had the building, the whole thing went up in just about the whole building went up with the pier being dug. I have a backhoe, and I dug out the hole for the backhoe with the backhoe, and then made a concrete pillar 4 feet down in the ground. And I put these 4 bolts sticking out of it, and that's what attaches to the steel pier, And all that went together in a combined time of about 4 days. But it was spread out over a couple weeks because I had to wait for concrete to cure and stuff like that. But it was a 4 days total time. So that was the fastest I've ever built an observatory in my life. But the observatory, that telescope that's in there, has the ability to track satellites, including the ISS. So I could get the ISS in there, and it would just scan across, and you'd see the ISS for the full time it's in the sky, and we can actually get zoomed images, do video, the whole 9 yards. And if we can get what I call critical focus, we'll see the solar panels easily, of the station, and we'll see, the GEM, the Japanese Experimental Laboratory module. We'll see the other modules that are on there, and we'll see the basic structure of the ISS right from here. and I mean, I just have to get the orbital elements downloaded, and I've got all the cabling for that.
Are you going to set up remote access to that one?
Absolutely. That's the whole idea.
Because if you're out doing some talk somewhere, I'm going to be sitting here trying to access your telescope and stream.
I'm going to give you the freaking login. You better be.
Paul, there you go. There's our answer. We have Paul when we have it, and then when Paul's clouded out or it's not good down there, we're going to take over Marc's telescope, and actually I'll let Paul run that from Miami.
And he can.
Yeah.
And he can.
There you go.
Yeah.
Paul, we have the answer.
Yeah.
There you go.
Yeah, and so that and then when I moved the whole kit and caboodle from here to Arizona in a couple of years, a year or two, actually, then I'm going to have about 300 clear nights a year.
Yeah, me and Paul actually talked about that the other day. We were because he was saying something about, I wish I could remember the exact word, but he was like, does Marc realize when he goes out to Arizona he's going to have company? We're going to make the trip out there.
Are you kidding me? I'm not going to. I would never turn you guys away. Are you kidding me? Yeah, you guys are fantastic. I mean, you had more to the science, okay, by doing this and by having these kinds of discussions than you can get from any book, You can read a book about the moon and the geology of the moon, all right? Or you can ask a question. And, if I don't know the answer, I'm not going to sit there and bullshit or, bleep or do anything. Amanda should have bleeped me, but I don't think she can do that. But the bottom line is that, I'm not going to bull anybody. I'm not going to try and pull the wool over anybody's eyes. If I don't know it, I don't know it.
Right.
It just so happens that, for some reason, I know a lot of these things because I've been a quote unquote astronomer since I was age 9, and then when I went to school for it, that became a serious thing. Then when I started studying exoplanets, planets around other stars, that became even more serious. And now I'm at the point where, to me, extraterrestrial life, the composition of the moon, composition of Mars, Europa, and Enceladus around Saturn, all of these things come into play in trying to understand where we came from and where an extraterrestrial species could come from.
Where my negativity towards these kind of people is yes, you're allowed to have your own opinion and whatnot, but if we're presenting you evidence and it's something that you can test yourself, okay, if it's something that you can literally go outside and do, or a certain test that you can do to confirm what the science is saying, and people don't do that, they just prefer not to believe in science, that's what starts to chat me the wrong way. And that's why I get pretty fed up with them. Yeah, I get fed up. I won't say fed up, but I'll say I tend to just push them away gently, okay? Like pushing, floating debris away from the front of your boat as you're passing through the water. Right.
When people start coming after me and totally disavowing any scientific knowledge to promote a theory that some unknown planet that we can't see millions upon millions of miles away is affecting the magnetic field here on the Earth, causing earthquakes, all that. Yeah. Absolutely. And I call it science-free crap.
And some of them are every day. Every single day, the world's going to end.
Oh, I know. The world... I think that the world's ended, 40 times in the last 6 years. And yet we're still here. And there are people that say, well, actually, it did end. And here's what happened. Here's why we were started up again.
But here's the funny thing. They think if they dig a little bunker, 10, 12 feet underground, they think that a collision from another planet, that's going to stop anything from killing you being 12 feet underground. You'll be totally wiped out along with everybody else.
Well, what people say, I just hope I'm on the other side of the planet from the impact. And it's like, no, you don't, right? Because there's a croquet ball analogy, right? I might have mentioned to you before, where you whack a croquet ball you have your foot on, and the croquet ball on the other side of your foot goes sailing. Yep. Okay, that's because the impact, that vibrational force, is conducted from the surface of where it hits all the way to the other side, isn't it?
Well, not only that, but the Earth is spinning, 2,200 miles an hour, and if you get hit by another planet, that's an automatic stop. Guess who goes flying 2,200 miles an hour when the Earth stops?
Yeah, you do. Yeah. Well, the thing is, okay, let's just say that it doesn't stop the Earth, okay? In fact, the Earth probably wouldn't stop.
Right.
And we might not even feel any earthquake or anything. It might not come to us for hours, or a couple hours. We might still have some time before we actually see or feel the effects. If that's the case, then we know that there's a conducted shockwave coming through the core of the Earth, and it's going to come out, say, over South America. And everybody in the Amazon basin, say, if it hits on the opposite side of the planet, they're gonna be just punched off the Earth from below.
Yeah.
And never know what happened. And it was because
they will reach orbital velocity very quickly.
Yes, they will. Well, not orbital. We kid about it, but yes, you're right. That's kind of close, right? We'd see that happening, and that's you see that on the moon. Okay, there's a large impact crater which has these massive multiple rings that are hundreds of miles apart. And out from each other. And that is from an impact on the opposite side of the moon. And that was an impact that came through the moon, conducted through the moon. And if you think about it, the sphere focuses on the inside surface. It focuses those waves into a point from the opposite side. So, all those waves are focused into a point. And, they get rerouted, and then they actually multiply, kind of like the rogue wave in the ocean, and you get this massive explosion out of the opposite side from where the impact is. And the whole point is that people don't realize that the impactor doesn't have to go through the moon, and of course it can't. Okay, it stopped relatively close to the surface on the other side, but the shock wave continues, and the shock wave travels exceedingly fast. Okay, through the moon, and that is going to cause massive damage on the opposite side. So when the asteroid hit Earth in the Cretaceous Paleogene boundary, they used to call it the KT boundary, but it's like the Cretaceous Paleogene, not tertiary now. Okay, whatever. We just agreed with the new terminology. That Cretaceous Paleogene boundary, 65 million years ago, when that asteroid hit off the Yucatan, okay, even that asteroid wasn't large enough to make a substantial impact on the far side. Okay,
right.
I mean, it was only a few tens of miles across, but it was enough to throw a lot of shit into the air. I did it again. Sorry, I threw a lot of stuff up into the air. Yeah. And when it did that, the dinosaurs. People think the dinosaurs died instantly, but they didn't. It took thousands of years or more, tens of thousands of years for the dinosaurs to actually die out. Right. And that's the thing that people have to put into perspective. So if we got hit by a major asteroid, okay, then massive dust would go up into the sky. We'd have nuclear-ish type winters for starting in the next season and coming down. And
so
for
our main problem would be plant life.
I was just going to say, yeah, plant life would die. Plankton in the ocean might die, and of course, I don't know how many folks listening know this, but plankton in the ocean is your primary source of oxygen on this planet, not the Amazon forest and not the forest. They're a close second, but it's plankton that are the primary oxygen generators.
Not only that, but right up the food chain it goes then,
Yes, that's right. And when plankton die, when plants die, then the plant eaters die. And when in the it's a Cretaceous boundary, when this happened, we find that the dinosaurs, they lived for a while, but it was over years and years and years that plants began to die out. Yeah. And then when the plant eaters didn't have their meals, they couldn't survive, then they died out, and then their genetic lines were stopped one after another, one after another, one after another. And what does that do? That makes room in the evolutionary track for another life form that could be naturally able to take advantage of that spot, that dearth of life there. And that's what we call natural selection. And that's something that happened all the time with us, and that's why we're here just the way we are. And, of course, we had 5 major extinction events on this planet, and the worst one being the Permian, the Great Dying, it's called, where over 90% of species died.
Let me ask you a question from Arnie in the chat. It says, Marc, with the exoplanets, there are groups that ask for volunteers to help them finding exoplanets. 4 found in one night by 4 Aussies. Are these groups worthwhile joining?
Absolutely, because you get real data. And what's nice is you put their software on your computer, and then you go to bed, and you let it crunch on your computer. If you don't mind having a slight accelerated electrical bill, which I wouldn't, because I've got like 8 or so computers running all the time, 24/7. So honestly, that would be a wonderful thing to do. Very much worthwhile. And then you actually get to look at the data yourself and decide if you think there's a planet there. And so you can actually decide. And what they do is they actually train you to examine what are called light curves. You actually see the light curves that are taken using this technique. It's called photometry. Actually, I did a whole thesis with photometry. And one of the things that I did was I examined stars, and they take away all the technical stuff you have to worry about, like extinction and other things that we worry about when we actually try to get real data from just the light coming from, say, a star. And you get that light curve where you see light start to dim from a star, and then it comes back up after a while. And that while could be half a day or 4 days, 3 days, depending on how slow the planet seems to transit across the face of the star. And if your computer is just crunching this data, and then it flags something, and you go looking at it and say, hey, yeah, look, I can actually see the light curve. I see the real thing right there. I actually see a planet causing the light to dim around the star. And see, it gives you access, in a sense, it abstracts you from them, but you get access to the biggest telescopes to actually see what's going on around these other stars. And it's very worthwhile. Great question. Do it now. Now. Did you do it yet? Join.
Yeah, there you go.
Mm-hmm.
Oh, what do we have here? I'm trying to find any more in the chat.
Yeah, I saw someone say Earth is flat, and it's like, oh, I'll skip that.
Yeah.
The Earth is flat. Shaquille O'Neal said so.
I recently found out I am blind in one eye. Are my chances of being an astronaut as dead as I think they are?
Afraid so.
Yeah.
Astronauts need depth perception. And I don't know how you could recently find out you're blind in one eye. That's sort of something you would know. So, must be something different. More to it than that. More to the story.
Then we have somebody in here that says he thinks the moon landings were fake. So basically, and we've discussed this before on here, but for the people now listening, how, like, we could probably do a whole video on debunking the moon conspiracy.
I did.
Yeah, and so did, there's also a video that's actually on the channel. If you click on the playlist, I actually have one from a channel named Curious Droid who did a really, really good job debunking all the stuff, the conspiracies from the moon landing and all that stuff. If you want to check that out, because there are basically answers to everything that they think they came up with that proves that it wasn't. There are answers for it, and testable answers once again.
Yes, exactly right.
So,
now, I know on NASA's Unexplained Files for one episode for one of the seasons, actually, it was twofold. They said there's a photo showing Alan Bean and his helmet visor, and it looks like there's a stage light reflecting in his helmet visor. And there were people saying, that is a stage light, it's all staged, it's all fake. Mm-hmm. And I said, no, actually, that's the streaking caused by lunar dust, because lunar dust is like little glass pieces, like glass. And if you noticed, if you took the time to do a forensic study of how Alan Bean was handling his helmet visor, he'd reach up with his left hand and flip the visor down. And we're talking about the gold sun visor that he drops. All right. Well, when he would reach up and lower that gold sun visor, okay, with his left hand, he's actually touching the visor with his left hand, which has lunar soil on it. All right, the left hand, and he would leave these streaks on the helmet. And so I actually recreated a lunar moon helmet here. I put the dust on there. I actually made lunar soil that acts just like lunar soil in every way. And it took me.
And just in case anybody asks, how do you know what lunar soil is made of? How did you access that information?
Actually, you could go see that publicly, but I actually at university where I was, they actually that university was responsible for putting the NASA retroreflector experiment on the moon. Mm-hmm. They built it in the workshop there.
Okay.
So,
just in case somebody is trying to bowl on it, I just wanted to make sure that.
No, that's fine.
You knew how you came to the same consistency is basically the same as moon dust.
Yeah, but the only thing I couldn't recreate was the glass nature of it. Mm-hmm. I could create the static charge properties, which you can look up in there's online journals which talk about the nature of the moon dust, and you could recreate those properties, which I did. And I used a special device to actually generate a static charge in the dust, because the dust was getting everywhere on the moon boots, and in fact, it clogged the air filters on the lunar module. And they had to work out a way to filter out the stuff so it wouldn't, destroy that lunar module filter.
Wasn't that some of that stuff sharp where they were actually cutting suits and whatnot?
Yeah, I think
of those silicon glass particles and stuff like that in them.
I think it might have been Jack Schmidt, and people in the chat will know, but he was supposed to do another moonwalk, on the moon, and he couldn't go out because at the base of his ankle, where his boot connected, the suit got ripped through to the insulation because of the harsh lunar regolith, the lunar soil. It's like little pieces of glass, and that stuff is really harsh. So I recreated that, and I used that to go on the helmets. And when it go on the helmet, when it does that on the helmet, it makes a little craze, like a little scrape when you move your fingers down. And because it's sharp and it's like in a small abrasive, like abrasive powder, like the polish something, abrasive polishing powder.
Right.
When you move your fingers down, it actually makes a streak. And I actually recreated like that little light that you would see, the little so-called light that was in the reflection of the helmet, by doing that motion over and over.
Let me ask you, when you do these little experiments,
Yep.
do you keep the items that you do these experiments with? Like, do you actually keep them for later usage?
Yeah, you'll see the helmet when you come up. You'll see
so
the
basically
Enceladus model I made.
I can shoot this stuff on video when I come up there.
Yeah, if you want to.
There we go.
I mean,
so we'll be able to see a lot of this stuff, when we go up there in a couple weeks.
Yeah. And in fact, I did the lunar helmet on the other side of the Enceladus model. I started with a spherical acrylic sphere, and I made a model of Enceladus. Because I had to demonstrate the geysers on Enceladus, so I made that into a geyser where I filled the sphere with stage fog,
right,
and I put 1 psi through it, pound per square inch, so tiny pressure. But out of these tiny little holes I put in the sphere, this stuff was shooting out at high speed, and on film it looked fantastic, and they used that for one of the shots to show how Enceladus worked. And then I did a squish ball showing how Enceladus is squeezed, by the interactions with Dione as it's going around Saturn. It's in a resonant pattern, and every time it reaches that certain spot, it gets crushed by the gravity just a little bit because of the gravity of Saturn acting on it, and then the gravity of Dione is pulling it into an elliptical orbit slightly. So at one point in Enceladus orbit, it's a little bit closer to Saturn, and then another point is a little farther. And what that does is actually causes Enceladus to flex. And so I was showing how when it flexes, little cracks would open up, and those cracks are the geysers that we see on Enceladus. And then when it's not flexing, they close up. And so that's basically what we did. That's basically what I did.
Awesome. I can't wait to see all this stuff too. But I want to get to some of the questions in the chat here because they were kind of building up a little bit. From K Music, you got Mark. Why haven't we found the faster ways to travel in space? Are we absolutely sure someone will die if they travel in a black hole?
With our current understanding, we're absolutely sure people will die if they try to go into a black hole. Yes. If we have an understanding 300 years from now where we can actually create a black hole to assist us in doing some kind of travel, then that may change things. But right now, we'll just be pulled in. Just before we enter the black hole, we'll be pulled into, and this is the part that's hard to understand, we'll be pulled into an infinitely long strand of spaghetti. Okay, falling into a black hole. And that's related to the immense difference in gravity as you get closer to that, what's called the event horizon on the black hole. Where the gravity at your head, if you were, say, standing, would be much different from the gravitational pull on your feet. And so you'd be pulled and stretched out. I'm sure it wouldn't be pretty.
Would not be pretty. And you got a question from Mr. Me. It says, if the atmosphere causes blurry images like you see tonight, with Jupiter and the moon,
yes,
because of atmospheric distortion, he says, why doesn't the Earth look like that from space?
Well, it's a very good question. And the answer is that's because you're outside of the atmosphere looking down at a planet. So it's the same reason that Jupiter, looks sharp and clear from telescopes in space, and Earth looks sharp and clear from telescopes in space. But when you're looking through actual atmosphere, right, from inside of it, you're subject to the atmosphere boiling and tumbling and doing all kinds of things like making convection layers. But when you see it from space, all right, and you look down at the ground, you're actually looking through the layer of atmosphere from above, and you're looking straight down, and you don't see that in the same way because you're not in the atmosphere. When you're in the atmosphere, then the air right at your telescope for 100 miles out, from where you are, can cause turbulence. Anything between your telescope and the end of the atmosphere
But
can cause
wouldn't
turbulence.
it be the same? Like, say, if you have a camera in orbit, you're still looking through atmosphere to say, like, say if it's one that's shooting the Google Earth images.
Yeah, you are. But the thing is, the difference is, you're not in the atmosphere,
Right.
and you're looking. You say you're at like 300 miles, okay?
Mm-hmm.
At 300 miles up, there's no atmosphere until about 100 miles up, okay? So for 200 miles, you've got just space, and your telescope is focusing now on the Earth, and okay, the distance through the atmosphere that you're looking is relatively small compared to when you're in the atmosphere looking out. All right, you don't have convective cells, but you do have disruption of your image. That's why when especially if you go to high power, that's why we didn't always have the ability, for instance, to read a license plate from orbit. We do now. We didn't for years, and that's because we didn't have the adaptive ability to alter what the satellite sees dynamically so that it can clear up the image. What's it doing? It's taking into account turbulence in the atmosphere between the edge of the atmosphere through which it's looking and the target down in the ground, which might be 100 miles below it. All right? So, relatively speaking, the Earth looks clear from space, but when you zoom in, all right, like we're looking here at zoomed images, when you zoom in, then the cumulative effects of the atmosphere take a toll. And it takes a toll whether you're looking at the Earth from space or if you're looking out at Jupiter, say, from the Earth. All right, you're still looking through atmosphere, but you have to be looking, at a highly magnified way. If you magnify, say, the Hawaiian Islands from space, you're looking from the ISS. You have a big giant telephoto, and you aim down and you look at it and you're saying, "Wow, I'm going to take a ultra sharp picture of Mauna Kea and look at all the domes." Well, you're going to take that picture and then wonder why it's kind of fuzzy, right? And that's going to be because of the fact that you've got between you and Mauna Kea turbulent air, and you're seeing it. Now Mauna Kea is 13,000 feet up, so it's got less air that you have to contend with, but it'll still be fuzzy. And that has to do with the fact that, again, you're trying to do a zoomed image from the space station or from orbit, all right, or Google Earth. And so you don't have the benefit of the tools to sharpen the image unless you have them on hand in a very elaborate way, like orbiting laboratories, orbiting science installations have, like the ISS. And so they can take pictures like that are sharp. The Google Earth satellite can take pictures, but you don't see the raw pictures from the Google Earth satellite. I've seen a few raw pictures from there because I actually worked on a project with the Google Earth satellite, and I had to go to Arizona actually, like once a month for about 5-6 months, and I was in the room where they were building the Google Earth satellite. And at the time it was called OrbView. It was a defense satellite, and then it turned out I thought it was a defense, a spy satellite, because everything on it was classified. Well, then I ended up finding out later that it was the Google Earth satellite. Surprise! Sergey Brin and Larry Page are in bed with the Defense Department. What a stretch! And these images that come down from the Google Earth satellite, I mean, they're nice, but they're processed, and they're processed beyond anything that you expect. And they actually do this predictive algorithms to figure out what the waviness is doing to the image, and they can kind of reverse it. And they adapt the image to it. And that is something that will be available for amateur astronomers. It's actually available now. You can put that on a telescope. You can actually like get a shot of Jupiter like we're seeing here, and in this shot here, 4 to 5 times cleaner than that if you use this little tiny adaptive system. But it's going to cost you. It's going to cost you a few $1,000s to put it on. But if you did put it on, there's a secret. You'd probably be the only one in the country that has one. Then that would kind of make your stream very, very popular.
Probably. I just noticed a comment from Blake Litchfield. He was talking to Amanda, but I'm going to bring this up to you. And he says, there are pictures of another planet next to the sun, and it's red with a moon. How do you explain that?
Oh, that's actually probably just the lens flare that we typically see. Whenever you take a picture straight into the sun, you will get Nibiru, Planet X, whatever you want to call it. It'll look like that. What it is it's actually just an internal lens reflection, because the lens of the cell phone or the camera, whatever you use, the sensor is being overwhelmed.
Or even, if it's a NASA-owned, say the SDO images and stuff like that, you'll get flares from them as well.
Yeah, I mean, but I don't think he was talking about those initially, but you're right. We end up having the SOHO satellites. Okay, you see people say, "Look, that looks like a winged dragon or something. That's a winged Anunnaki." Okay, and I look at it and say, actually, no, that's most likely a cosmic ray hit, because that's what they look like.
Right.
Cosmic rays.
My friend Dazza, the cameraman, a lot of people, he rubs a lot of people the wrong way. Like, a lot of people hate Dazza. His real name's David Gregg. He's from New Zealand. But one thing I can tell you about Dazza is he does his homework, and he literally makes it his mission to debunk Nibiru channels or UFO channels or stuff, and actually hits them with real science and provable science. And he gets so much hate for it. Like, he gets people calling him a government agent, which we have been called that, obviously.
So have I.
NASA shills, government shills, whatever. You had guys threatening to come to his house and punch him in the face. And the guy is nothing but a gentleman, but he does rub people the wrong way because they think he's being cocky when he's actually just being nice to them and trying to, tell them the science behind what they're seeing, and they just don't want to hear. They just want to believe, whatever they want. But,
it's like, welcome to my world. That's what I see. All the time. And I saw on one particular site, somebody said, why do you even listen to this D'Antonio guy? Have you seen who he's working for? Look at his website. Yeah. He's worked for these 3-letter agencies. And I actually responded to that, and I said, wow, it took you one click to get to my client list where I list those openly. It's not like I hide it.
Here's the thing, Mark. You know the reason why I'm even talking to you right now? The first night I heard you was, of course, on Bill's stream. And as you were talking, I was just kind of sitting here looking up stuff, and everything you were saying was coming across as verified through whether it be peer articles or whatever, science review. And I was like, this guy knows this stuff. And everything that I looked up as you were talking, and then I was like, okay, this guy actually knows what he's talking about, which is why I started talking to you, and then we created this big thing, and now you're chilling out on the channel, and I'm heading up to check out all kinds of cool stuff because
you're coming up here. I
can trust in what you have to say. It's not theory. Well, there's a lot of theories out there, but it's scientifically backed to the best of your knowledge. That's why and that's why I have you on here so much, because that's what I want to portray to the YouTube community, as much science as we can.
Yeah, you do a fantastic job, and Paul does a fantastic job. You guys are actually, like little blowtorches for the whole streaming community. And I'll tell you this, I make no secret of the fact that you convinced me to do my stream, okay, which I haven't done yet. But I just finished actually installing the Wi-Fi adapter on the observatory computer today, so I'm ready to go. But it's cloudy. And I probably wouldn't have gone tonight. I'd like to have some time to run through a test, But the bottom line is, you guys, made me feel that maybe this is a good forum to start a stream, But I would want to do it in conjunction with you guys. I wouldn't want to step on you or anything like that. I want us to kind of be in this together, so that we're kind of involved together.
My feeling has always been, the more eyes, the better. So whether it's the little streaming channels, that aren't really, because it's been a year and we're almost at 20,000 subscribers. The only reason we're even that high is because some channel down in Brazil posted us. The guy had 7 million subscribers, and next thing you know, we're getting it on Onslaught. But we slowly built that, and people wonder why we have so many moderators and everything like that. Is because we try to keep this educational, because we do have colleges that use this stream. We have, schools. Especially David that comes into the chat. He's a teacher. He uses our, stream for his classes. And lets them jump on. And me and Marc are actually doing a private stream to that class before the end of their school year, which I guess still got to talk to you about. It'll be sometime after our trip to New York, because I think he said that their last day of school is June something. So we'll do a private stream to that classroom where they can ask all kinds of questions and whatnot to them. But
sure.
Yeah, I always said the more eyes, the better. And when me and Paul first started, I was doing the moon, of course, with a way smaller telescope, and Paul was doing his thing with his big telescope. And it just seemed right that I had the YouTube channel, and he was on a different medium. And then I was like, okay, well, instead, I could also tweak it on this end with the software that I have, and that's kind of what made us, pair up. And then it started blowing up, and it's like, yeah, I mean, we both love what we do, whether we have 1 subscriber or a million. We'd still be doing the same thing here, doing the same thing. Because YouTube, number one, automatically stores and records everything, which is something that we love.
Yeah, and I did a couple test streams, and you know what my stream's going to be? It's going to be the Sky Tour live stream, and I'm going to take people dynamically. Yeah, it would take people dynamically through the sky, object to object. The camera's going to change positions, every so often, and I'm going to talk to people and tell them what we're looking at. Star clusters, old nebulas that are places where stars are being born.
Right.
And the nice thing is I have a camera that is going to be able to show them these objects live, even the faint ones.
Exactly.
And if you can't see it in the camera, I can do right through the stream. I can actually take a picture of the object for, say, 4 seconds, and then it'll appear on the screen right then and there, a picture taken right there live, so they can see what it actually looks like in a variety of ways. And at the same time, I want to tell people about how we're going to accomplish creating all these, educational outreach programs with this, and the observatory's main purpose is to do that the Sky Tour live stream, and then the secondary purpose is to test our UFOTOG equipment, which is our UFO hunting equipment. We're going to have it as a controlled environment to test each individual component as they come online. Which I know all this stuff here, but I'm telling them for the benefit of the people that who haven't heard it, but I think that's kind of cool, and I'd like to, I would be love to have you come on as well and be part of the stream, on my stream at times, because I think that'd be kind of cool to have you on board, just to hang out and to talk to us about it, and
because if we're going to have you doing deeper space stuff, you got Paul pretty much covering the moon and localized planets, you covering nebula, and then we got Bill covering total sky, meteor showers and stuff. So we are somewhat already a little network.
Yeah, and I think that's really cool, and I'm in Connecticut now, but I'm going to be out in Arizona by the time this is flying high, and I'm thinking that's going to be like I said, a year or two. But the streams are going to start almost very soon, and I did them off my YouTube channel, which I guess is just my name, Marc D'Antonio, right?
Yeah, and Amanda, can you link Marc's channel in the chat there for us? But I do want to. Oh, there was a question here I wanted to. I just saw from. Did you see that one from Rosendo Preciado?
I almost did. It went off the screen and I didn't scroll it down. But
I'll read it for you here. It says the Earth is on an axis rotating, miles per hour. It rotates around the sun, blank miles per hour, and it also flying through space, blank miles per hour. How is it possible to have the North Star and the time lapse? The stars make perfect circles.
Oh, that's actually a very good question. Actually, you know what? That points to a fundamental understanding of our place in the solar system and in the galaxy. And I can answer that actually fairly quickly. Now, the stars are very, very far away. So when the Earth is on one side of its orbit, the farther stars don't seem to be moving. And if we go on the other side of our orbit, the exact opposite side of the sun, the stars that are far away still look like they're very far away and have not moved. However, the nearby stars do move. And they look like they've moved against the background of the larger stars. That's the parallax effect, okay? And that's like when you hold your finger out in front of your face and you far at arm's length and you blink your left and right eye, you see that your finger seems to shift against the farther background of the wall. Well, if your finger is the nearby stars and the wall are the farther stars, you can see that your left eye, one side of the Earth's orbit, and your right eye, the other side of the Earth's orbit, can actually see a movement there, and that's the movement we see. I actually did a whole research project when I was getting my astronomy degree on the parallax program that we're running at the observatory, and I was taking parallaxes of stars, and that parallax thing, that's how you actually see the visible universe changing for us. Now, because the stars are so far away, for the most part, the stars don't appear to move, and that parallax is really, really tiny, even for the close stars. You can't really see it with your eye at all. You have to see it with a very, very powerful instrument. So now the Earth, as you said, is true. It's spinning on its axis. Well, it's spinning on its axis, and so that takes 24 hours to occur, right? It spins around. But a nighttime spin on the Earth's axis that you might actually be able to take a photograph in is only going to be, 10 hours at the most before you start getting the light of the twilight. And depending on where you are on the Earth, you might get a little more, a little less. But it's the spin of the Earth, which is actually fairly stable, and that spin creates the trailing of the stars in the sky. So it doesn't matter where we are in the Earth's orbit, okay? The Earth is still facing the same direction, okay? And so that's why we actually see these star trails, they're called, and that make this around the pole trail for long, long time exposures. And don't forget, those are taking place in the space of less than 1 day, and it takes 365 days to go around the sun. So that's only a tiny fraction of time, and you're only really seeing the Earth's rotation there. You're not seeing the Earth moving around the sun at that point.
But not only that we are shifting over time, and in about 10 or 20,000 years, that won't be, our star.
Yeah. I was not gonna talk about the fact that we wobble like a top. That's called precession. Right. But yes, over time, it takes 26,000 years. The pole and the whole axis of the Earth is sort of wobbling like a top that's running out of energy. No, the Earth's not running out of energy, but a top that's running out of energy. You know how it wobbles, as it's turning. Okay. Well, our Earth's axis is doing that. Now, the question as to why it's spinning like that and why it's sort of wobbling and has this precession process going on every 26,000 years. So that means 26,000 years to come back to roughly the same position, right? That 26,000 year precession is due to a lot of things. Some people say, well, we were impacted, something created the moon, maybe it happened then. It's possible that had something to do with it. We'd be silly to say it didn't. That could be residual energy left over from the impact. Because to a planet, 4.5 billion years really is not, that's a long time, but not to a planet that's evolving. And the other thing it can be is the fact that we have these oceans. And the oceans have a tidal bulge. A tidal bulge induces forces on the planet that cause it to kind of torque over a little bit. And that could be responsible more so even to cause this little bit of spinning like a top. Now, had we not have oceans, then maybe that little top motion like that spinning top motion, where it's wobbling on its axis, might not be as pronounced, if at all. And if we had no moon and no oceans, then we might not see that at all, without anything. It might just be spinning perfectly fine. So these motions are all due to those precession motions are all due to the fact that we have oceans and potential impact from when the moon was formed early on. But overall, the stars are so far away that in the course of less than 1 day, time-lapse photography of the sky will show just what we see, a complete a complete circle of the stars. Not complete because we can't see the stars for 1 full day, but a big arc around the North Pole. And no matter where we are in our orbit, we will still see the same thing because we can't see the parallax of the stars that are nearby in any way on a wide shot of the pole doing these star trails.
I wonder what's causing that blinking on the camera.
What's blinking? Is it doing black frames?
I think it's something to do with
or the white,
with the image processing. Yeah, it's it just causes it to.
Paul's got what's he got for it? 11, right? 11-inch telescope.
Yeah, he has a 10 and 11.
Okay, well, that looks to me like
strobes.
It looks like he's stopping down the imagery because it's too bright. An 11's too bright, and he might actually get better imagery just by putting a cover over the front that has a small 4-inch hole in it, or even a 3-inch hole, and then that's more than enough moonlight to see the moon beautifully. Because you don't need a light bucket for the moon.
Dunster 2007 asks, why can we sometimes see the moon in the daytime?
Well, you know what? To someone that's not used to that or not doesn't think about that, that could be a perplexing question. And the reason that we see the moon in the daytime is because it's bright enough. We can also see Venus in the daytime. I don't know if we knew that, Dunster, but if you know where to look, and I've shown people and coached them when Venus is out in the daytime, I've said to them, I see Venus, and they'll say, wait a minute, what? And I actually taught this when I was teaching, taught people how to see Venus during the day. And it would take about 10 minutes for some people to see it, but when they saw it, they didn't want to take their eyes off it because they'd lose it, you know? And it was really cool. And so if it's bright enough, you can see it. And the moon is big enough in surface area, relative, surface area that you can see with your eye, that you can actually see the moon during the day. Now, if the moon was a new moon, that means that you can't see it at night or during the day, and that's because it's all the way over on the side of the sun, and it's fully, it's still half lit, but the half that's lit is on the other side of the Earth where you can see it. You can't see it because it's beyond, it's on the other side of you. So without that ability to see it, the new moon would never be visible. A crescent moon, especially like just a 2-day-old moon where it's just, and by that we mean 2 days into its cycle, a 2-day-old moon would not actually have the ability to, you might not see that either because it's still not quite bright enough to be seen. It has to be just a little bit brighter.
And just to clarify, I have people that ask sometimes, what's the difference between waxing and waning? And I'll let you explain that, since you'll probably do it a lot better than I do.
Well, wax on, wax off, right?
Yep.
Waxing, it's a strange term. Basically, it means growing. It's when the moon is starting into its orbit. Starting in its cycle around the Earth once. Going around the Earth once as we start the lunar cycle. We see the crescent moon on the horizon at sunset, and that's the beginning of the lunar cycle to us, because that's what we see, right? And that's a waxing or growing moon. So it grows and it moves farther eastward every day, all right? And like about 15 or 20 degrees per day. And when it's a fourth of the way around the Earth, it looks like it's half lit from here. It's always half lit. Okay, it's a sphere. But if you think about the shape of the apparent amount that's lit in the sky, it looks like half. So the right hand half is lit, and that's called first quarter. Okay, and that's about like I said, a fourth of the way around its orbit around the Earth. Then, as it travels a little farther, and not quite before it's full, but just a little bit farther, where it's in that lower half of the sky toward the east, when the sun is setting, basically, that is the gibbous moon, which we're seeing here. I believe we're looking at the waxing gibbous, and again, growing gibbous, and it's just before full moon. The full moon when it's actual full moon, as soon as the sun is setting, the moon is rising as a full moon.
And I should mention, isn't it true that when the moon is full, it's literally only full for maybe a couple hours? At actual 100% full.
Yes.
Before.
Yeah, I mean, if you want to.
Again.
Yeah, be technically correct. Yeah.
Well, that's why a lot of people are like.
To us astronomers, it's an annoyingly long time.
Yeah, because a lot of people ask, like, say, if it's due to be full on, say, a Sunday morning at 12:30 a.m., people wonder why I put a full moon on the night before, because it's pretty much like, okay, we're at 99.8%, and by 1:30 a.m. we're going to be at full anyway. So it's like, because usually what I used to do is I would take where it was in between zenith and setting, and I would take that average, and that's what I would put as the percentage illuminated. You know what I mean? So I would just take the average between the two. But then,
Yeah, fair enough.
Yeah.
Fair enough.
Because throughout the night, we're gaining if it's waxing, and we're decreasing if it's waning. So I figured that would be a good way to do it. But a lot of people's like, well, what is full moon's not till tomorrow? This is a lie. It's a fake video. And I'm like, okay, well, it's actually full at 4:00 in the morning. We're not going to have it, and it'll be down to 98% by tomorrow night. So It's actually this is the fullest that we're going to see.
Yeah. And Matthew Calloway, actually in the chat, he's questioning why we don't see stars, satellites, or space junk on the ISS live stream. Well, that's also a good question, and that actually has to do with cameras. It doesn't have to do with... Same reason
you don't see them here either.
That's correct. Because let's use the Jupiter stream that we see. When you see Jupiter with its cloud bands, you don't see Jupiter's moons. But when Paul allows the planet Jupiter to become way overexposed, then you see the moons. Okay? The reason that's happening is because he is literally cutting out the light so that you can see very, very bright Jupiter as a disk with its cloud bands. But to do that, you lose the relatively less bright planets, moons. You lose those in the background. They're still there, but you can't see them because the camera is now reduced in its opening, its f-stop, and it's actually shooting to expose the planet and not the moons. To see the moons and to see the planet at the same time, you have to be clever about it. And in a video, you can't do that because the video cameras are not clever. But that's how that works. And so when we look at, say, the Earth from space, from the ISS, the International Space Station, I would ask you to look up the videos of the space station going around the Earth at night. You see a beautiful Milky Way and lights on the ground. You have to look at the night side transits of the space station around the Earth, and you can see auroras, you can see Milky Way and stars galore. There's plenty of stars, all right? Because the night side of the Earth, okay, is dark. On the bright side of the Earth, when you shoot so that the bright side looks properly lit with the clouds, which are very, very bright, reflect a lot of light, when you look at that bright cloud base on the Earth, to expose that to be very bright and not just blown out white. See, look. See how it looks? You see Jupiter? It's bright white right now? Mm-hmm. There's the moons of Jupiter, see, on the right? Okay? And once the words go away, you'll see it. Yeah. See, left and right, you see the moons. Right? That's exactly what I was talking about. But it's overexposed. Just like if we overexpose the Earth, we'd see the stars. Okay? Now, when he goes down and he now cuts down the iris, the f-stop, effectively electronically or however he's going to do it, you'll see the moons go away and you'll see the planet's cloud bands. And that's the trade-off. You can't do both. Or Jupiter just vanishes, as we just saw.
That's usually when he takes it out of overexposure. Yeah.
So now you can see, when you see the bands, you're going to see no moons. And, that's how that works. So it has to do with camera exposure, all right? And that's why we don't see stars in Earth orbit, except on the night side of the Earth.
Which is another reason why NASA does a lot of layering of their photography and whatnot to make stuff visible, because you usually can't see it through a single picture.
Right, and that's the same reason we didn't see any stars on the moon, because the moon, that gray moon surface was actually pretty bright. Okay, it only
80% reflective or something like that, wasn't it?
Well, I think it was actually much less than that, but the astronauts' suits were 80% reflective.
Yeah.
And so when they were on the back side of the lunar module, the brightness of the reflection of their own spacesuits is what illuminated the darker side of the module. Otherwise, it would have been pitch black. Because the moon only had like a 13% reflectance or so. It wasn't very much.
Right.
However, to shoot that correctly and to shoot that at the right gray level so that nothing was overexposed, you totally knocked out the stars to do that. And because that was shot on actual film magazines, we lost the ability in processing later to actually create composite photos that might have shown the stars. We didn't have what are called HDR, high definition photos that can actually show all these the separate exposure layers.
Mm.
Yeah.
We have a couple people in chat that feel sorry for us because we don't know what we're talking about.
All right, well, we'll invite them to come on and tell us what we should be talking about then, huh?
Yeah, show us your science.
Yeah, show us your science, man. Do you science? Do you science? I science. Do you science?
Let's see. Tell me why they have never done a 360 view of space. Okay.
That's fun. I see another question about the craters.
Go for it.
Obviously, miles deep, if we can see the depression from here. Not obviously. They're just, the low angle of the sun could create a shadow. And then they're not usually miles deep. They're actually sometimes only a few thousand feet deep. But if the angle of the sun is low, you can see that relative dark shadow very easily. So you can see them like that. Many of the moon craters are actually less than miles deep, but you just have to know your moon stuff to know how deep they actually are. But there's peaks and there's peaks that are like 20,000 feet tall on the moon, stuff like that. Like some central peaks are very, very high. And we see central peaks in what kind of crater? Complex craters, right? Good job. Yeah.
My.
Yeah, I'm such a winner.
We had somebody ask too, why do all the craters look like they're directly impacted and not on an angle? I know we had talked about this before, but you can answer that.
Well, there's a couple reasons actually. First of all, at the terminal phase where the craters come in and hit the moon, many of them did hit flat on, but a huge number of them did hit obliquely. Okay, and we see them. You can see oblique craters. In fact, you see bounces. You see areas where an impactor hit the moon, and then blew out a chunk of material, which then went farther down the surface in the downrange direction of the impact, and made another crater. And then sometimes a crater after that, and it made a nice string, bam, 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 bam. Like stuff hitting the moon, like in constant pits in the following the original crater. But the other thing to keep in mind is that on the dark side of the moon, for instance, we know there's seemingly more craters. Now, the moon was pretty evenly cratered, but on the front side, the side that's facing us, the question is, why is that side facing us? Well, it's facing us because the moon is so close to us that it's tidally locked to us. That side of the moon is tidally locked, meaning that the moon goes around once on its axis every time it goes around the Earth, and that's tidal locking. The TRAPPIST-1 exoplanet system has 7 planets closer to their sun than Mercury is to ours, and every one of those planets is tidally locked. The same face of the planet faces the sun. And
I always wondered that about a tidally locked planet. Is it possible to say create a base right around the Terminator line?
Oh yeah, I think that'd be great, especially on let's say on an exoplanet. Okay, I think this is a cool idea. You could run a tour company and really clean house. You could run a tour company that brings people to tropical paradise where the sun is always at noontime all the time. You get the tan of your lives, and then you can run the sunset tours where you can take people to see sunset, and they can stay there for 6 weeks and see sunset all the time. Another object was passed in front of the moon. That was a foreground object, you could tell.
Because of like some planets and their extreme temperature, like obviously the moon has this as well. The extreme temperature differences between the shaded side, and the lit side.
Or the shade of craters and the light side of the craters.
Right. So if it's tidally locked, and it's like facing the same side as facing the home star at all times.
Mm-hmm. Yeah.
So you would obviously can't be right on the Terminator line because that would still produce way too much heat being that close. But you'd have to be, say, 200, 300, 400 miles away, like back from the Terminator line, where it would be actually an average temperature.
Well, that actually depends on the kind of star we're around, if we're going to talk about that. Because let's take the TRAPPIST-1 system, for instance. Okay, there's components B. These are the planets now: B, C, D, E, F, G, and H. Okay, now
alphabet.
The alphabet. Oh, E. Dun, dun, dun. Okay, yeah. So anyway, E, F, and G are suspected to be in the habitable zone of that star. Yet they're very close to the planet. They're very close to the star. They're closer than Mercury is to our sun. And we say, well, the surface of Mercury could melt lead. It's so hot. So why aren't these planets, in that position? They're not in that position because the star they're circling literally has 8/100ths of the power output of our sun. So that's the habitable zone for stars like that, and they're called ultra cool red dwarfs. And it doesn't mean ultra cool like yay, man. It means ultra cool as in low temperature.
Sweet, bro.
Yeah, man. It's like red dwarfs, just like the TV show, man. If you ever saw Red Dwarf, tell us in chat. It was a great show. And
I'm more of an Alf fan myself.
ha! You kill me. I kill me.
Yeah, right. Remember that show? Stupid.
Of course I do. Yeah.
Little
Willie,
puppet.
where's the cat? Here, kitty, kitty. You're lucky.
Or as my dad used to call him, Little Chewbacca.
That's right. Oh, that's funny.
But anyway,
Oh, yeah. So anyway,
totally forgot what you were talking about, didn't you?
You think I forgot what I was talking about?
I don't know. Did you? I did.
Yeah. No, I know, but we were actually talking about we were talking about the E, F, and G components of the TRAPPIST-1 star,
Right.
and saying how those planets are tidally locked, but they're in what's called a habitable zone, which means liquid water could exist on their surface. Now, if that's possible, then that means that the noontime sun there might be the equivalent, say, of an Arizona noontime sun, which could be, fairly warm, but liquid water could still exist. Or it could be hotter, or it could be slightly colder.
But being like some of the heat that's produced, I'm talking about more like radiant heat. Like even though you're in the shade, you're gonna, especially if it's 600 degrees on the sunny side, and negative 200 on the shaded side. You're gonna have that mileage distance in between super hot, even right around the terminator line. It's not gonna just be sun hot, shade cold. You're gonna have some mixing of.
Right. But remember the definition of the habitable zone. The habitable zone is that place where liquid water could exist. And if it's 600 degrees, liquid water can't exist.
Right.
Okay. Now, and of course that depends on pressure. That depends on the atmosphere. Okay. Liquid water, boils at 1 atmosphere, right, at 212 degrees Fahrenheit.
Right.
But if you climb a mountain and try and boil water, you'll find that it boils at a lower temperature. If you go into space and go out of your capsule and take out your water, it boils away instantly because you have a zero, it has a vacuum. Mm-hmm. Because remember, the thing that's more important to water boiling is pressure, not temperature. I mean, it is related. I mean, PV equals nRT is the ideal gas law, right? And pressure times volume equals N times R times temperature.
You people in chat better be writing this down. There's a test later.
I think it's to the 4th power. So that said, when we look at the relationship between pressure and temperature, we see that as temperature goes up, pressure has to go up. As temperature goes down, pressure has to go down. Right. When pressure is 0, there's no definition of temperature. Meaning in space, there's really no definition of temperature. It's what is radiated and conducted into a surface of something. So if we look at a planet that's tidally locked, if it's in the habitable zone around, say, the TRAPPIST-1 system, that means that liquid water can exist on its surface under the conditions of the planet, should those conditions be like Earth. I mean, there's a lot of caveats here. So it'd have to have an atmosphere that's thick enough so that water can exist as a liquid on its surface. And then conditions to make life like us, again, that's the caveat there, life like us, will be in effect. But if it's not life like us, then maybe conditions can be a little different. Maybe the temperature can be such that the water will be, say, 200 degrees or 180 degrees. Not conducive to life like us, but maybe to life not like us. And so it's possible life could develop that way. Now, if that's the case, either way, as you move away from that noontime sun, as you said, and you're correct, as you get closer to the terminator, the temperature is going to gradually get less and less and less on that surface. Again, provided you have enough atmosphere, etc. But if you get to that terminator, technically that would be the sunset location, and that might be kind of chilly if the temperature is only, say, 80 degrees at the other noontime location. If the temperature is 180 degrees at the noontime location, then maybe it'll be 70 degrees or 80 degrees at the sunset location. So it depends. But then when you get around the backside, the temperature will, of course, be a lot less. It could drop. And maybe the weather conditions will be such that, even with atmospheric mixing, which will occur, and the atmosphere will mix and the climate will bleed over from the front side that's always hot to the dark side, In fact, the hot air will tend to go to the cold side, and what will happen is it'll end up becoming mixed to some degree. And if it does that, then I think what we'll see is that the dark side won't be like absolute zero, but it might be like -10 or whatever, -5 or 0 or maybe 30. On at the midnight side of the dark side,
Right.
but near the terminator, it might be a little warmer. So, there's ways that these planets can actually be livable, but these kind of stars tend to give off a lot of ultraviolet radiation. So there's also the possibility, a strong possibility, in fact, that these stars blew away. These types of stars blow away the atmospheres of any planets because of the high ultraviolet output and the X-class flares that are constant in their early development. And if that's the case, these flares and this constant barrage of high energy ultraviolet radiation would tend to strip away atmospheres. But if it had a thick enough atmosphere and if it had a magnetic field, which of course is critical, without a magnetic field, then the surface is sterile, there's no doubt. It's like Mars. If it had a magnetic field, then life could possibly develop. And that's why the TRAPPIST-1 system, even though it's less attractive the more we know, it could still be a potential still potentially harbor some kind of life.
Let me ask you, Mark. Are you able to hang out some more tonight? I mean, do you have any plans or that you have to get to or anything like that?
Not at the moment, no.
Sweet. So you're able to hang out with us for a while longer?
I could.
Because what I'm going to do is I'm actually going to take a break right now so I can refill beverages, and so we're going to take like a little 5-minute break, and that'll allow you to do whatever you got to do on your end.
Okay.
And to the chat, smoke them if you got them. And then pretty soon we'll be back to Zooming once again. So we're going to take a little break for a couple minutes, and I'll just jump back on the mic here whenever we're ready again, Mark. So feel free to mute your mic or whatever you want to do. And in about 5 minutes, we'll be back with more with Marc D'Antonio.
I'm going to go check out the weather.
Check out the weather. All right, guys, we'll be back. Back from the break. Let me get Mark back in. There we go. Mark, you're still with me, right?
I am still here.
Great. All right. So what's been going on, chat? You kids been behaving? I hope
Yeah, they're
so.
behaving.
Let's see. Paul is still on the wide field, which I should have changed that by now. That's my fault. I seen a guy come in and he said, "I get better views from my Kmart telescope," or whatever he said. I was like, "Holy moly!"
Well, that's one heck of a Kmart telescope,
Yeah,
I gotta
right.
say.
Point me to that Kmart.
Yeah.
I like the people that also come in and go, "Oh my, what is that? Is it the Sony D900 or whatever it is?"
Well, the P900?
Yeah, the one with the big zoom on it.
Yeah,
Like,
I got
look
one
at
of
that! I
those
can see
cameras.
with that. I'm like, yeah, that's a pretty good zoom for that camera, but I mean, man, it doesn't even compare.
Actually, no, it doesn't. The P900 can actually do better than what we're seeing here, actually, in terms of zooming.
Mm-hmm.
But if we want to really, really get there and just like dive in and say, well, what's better?
Right.
Clearly, a full-blown astronomical telescope with proper lenses is going to be far better than the P900. It has more flexibility. There's more you can do with it,
Easily.
than the P900. I have a P900. It's beautiful.
I haven't even paid attention. Where is the moon right now? Is it at zenith or past zenith right now?
Not sure.
I haven't checked in a while.
I can tell you in a
usually when it's
second.
oh, here we go. Paul texted me. I didn't even hear it. Okay. He said he was taking a break too for a little bit. So, and that was about 15 minutes ago. So
That was an hour
he
ago.
should be back. He should be back too. So he kind of took a break the same time we did.
Yeah.
All right.
Yeah, actually, the moon is past zenith a little bit. It's kind of on the downslide now.
Yeah, he just switched it over. Actually, I was wondering. I was gonna say because usually when it's at zenith, like Paul is on it, he's ready to go.
Yeah.
Yeah. So now we'll get into your $300 Kmart telescope views for you, buddy.
Yeah.
You think some people just talk to hear their own voice?
Maybe so, but I can understand why he'd say that because he's seeing this view,
Yeah,
and that's kind of what you would see.
Yep.
But as I said, the flexibility shows up when you see him zoom in. Okay. When he zooms in, then all of a sudden you're seeing a view like we're seeing here that's coming up, and this view is better because now you can actually scroll across. It's also being tracked. That's another thing the Kmart telescope may or may not do. It depends what you buy.
And tracking, I mean, you can get crappy tracking too. I mean, when you go to a tracking scope, you might as well spend the money and get a good one because if not, you'll get kind of fidgety movements and whatnot. So I mean, Paul's got top of the line tracking system in that thing. It keeps it real.
Yeah.
I mean, you guys noticed. I mean, the thing was pointed right at the moon and it didn't flinch once.
Right.
And he can stay on this shot right here with the craters, and follow it all
And
the way
leave it.
down to when the moon sets if he wanted to.
That's right.
And Paul is
The nice
really
thing
good
is-
at what he does too.
He is. And these telescopes are designed now, especially he has a C11, I believe, Celestron 11. And that telescope has a very nice computerized mount so that it can go anywhere if he wants to. And this is why, what you're seeing here, this is why the Kmart telescope, falls away because you can't do this with one of those cheaper telescopes. And this is actually where the light bucket helps because with the larger amount of light, you have more flexibility and the better range of focus.
Well, not only that, but a lot of people confuse. Like a lot of people think that they could take a, let's say a $70 Kmart telescope, and say they get an attachment for their P900 or whatever it is. They think they're going to get this kind of view out of that. Now you will get zoomed in views, of course, but then you start looking at focusing issues. With how far you have to be from the lens and stuff like that. You're going to need a focal reducer and all that other kind of stuff. So you're not going to get it this clear no matter what kind of camera you put on a cheap telescope. It's just not going to happen.
True. That's true. And telescopes have their own limitations, their own calculations you have to do to find out what the maximum useful power is of a telescope. And usually it's the focal length divided by the power of the telescope. If you take that and divide the focal length by the power, that kind of gives you the maximum useful power. The actual, I'm sorry, not the power. I I'm trying to get the formula so I can just say it right, because I wasn't saying it right.
Well, if I can recommend, if anybody wants to see how a Dobsonian telescope is made, there is actually a documentary on YouTube of John Dobson.
Oh, great guy.
And it actually goes through where he's teaching a class on actually these people making and they're doing it by hand. They're not doing it with machines. The only kind of machining they use is when they go get the the glass plated, with the aluminum oxide or whatever it is. Besides that, they are grinding these big pieces of glass by hand and getting the curvature and the focal points just right. And the amount of work that goes into it is just amazing. It's about an hour long. So if you want to check it out, just look up, Dobson telescope making or something. You'll see it. It'll pop right up. It looks like it's from maybe the early 90s. But even in his old age at that time, he was doing it by hand himself in his garage, building his own, compartments, and with the way they turn and everything. It's really, really neat.
Yeah, he had more patience than me. I mean, I ground a mirror for one summer, because that was part of getting into telescope building to see if I could do it. Mm-hmm. And it was only a 6-inch mirror. 6-inch mirror.
Yeah.
Okay, and we had to make what's called a pitch lap. It was the former, and then you add abrasives to it, and then you just grind by hand. Now there's machines that do that now.
Right.
But we just ground, and it took all summer to grind it down to the point where we could actually get it silvered and be a real mirror. And it was really something. And if you screwed up, if you got a little extra piece of grit in there that shouldn't have been in there, then you blew it. And you'd have to regrind the curvature of the mirror. And the curvature of the mirror is something you had to keep consistent all across the surface of the mirror.
Yep.
And that's still the case. Now, take that to the next step. Now, nowadays we actually have these multiple mirror telescopes. The multiple mirror telescopes are the ones that actually have little tiny hexagonal elements all next to each other.
Right. Which is how they do a lot of the bigger telescopes these days, just on a bigger scale.
Right, like at the Keck Observatory.
Right.
Okay. And Mauna Kea in Hawaii, and these mirrors are separately mounted and separately able to be steered around, and they do that so that they can on the fly modify the image to get the best quality out of the image.
Right.
And whenever you have multiple mirrors like that, then you have another thing available to you, and that's called adaptive optics, and that's something where you actually change the optics in a millisecond to the image that's changing due to the convoluted air that's hitting the telescope mirror.
That's our goal. Our goal for this channel is to one day be able to get adaptive optics down there to Paul. And the cheapest one we found was like a 3 laser system, I think, and it was $23,000.
Yeah, I thought they were about $12,000 actually, and I was thinking, that was actually more reasonable, as unreasonable as it is.
Yeah.
But implementing it is expensive, but getting it to work is just dynamite.
Yeah.
I mean, this image here of Gassendi crater, this would actually be stunning with AO adaptive optics.
Yeah.
And those shimmering waves you see from the air would not be there.
Maybe we could talk Dave Shock into finding us a financial backer, since he's pretty good at that. Hey, we need a financial backer to give us some adaptive optics, so we no longer have to put up with atmospheric conditions.
Yeah, well, I've looked into AO too to see just what's available, and there's some actually interesting stuff out there to make a telescope be able to see clearer.
Yeah.
Yeah.
Obviously, I'm sure Paul would like to hear about that when we come up there too, just to see if there's anything within reach. Because I mean, as I said, anybody getting into astronomy, you got to know that this, even as a hobby, is not cheap.
No.
Not by any means. I mean, you're talking an expensive. I mean, I was talking to Bill one night. He's like, "Man, why couldn't we pick a cheaper hobby to do?"
Well, I mean, just the camera that I put on the telescope. Again, if you're going to do a live view of the sky, you actually have to have the ability to change the sensitivity of the camera, so that for faint objects you can pull up the sensitivity, and increase it so that you actually see the object live in the camera view, and then for bright objects you can tone it down. Modern digital cameras can do that a little bit, but they can't go too many f-stops, as they're called, too many clicks of the camera. That is the exposure settings, or the iris, the opening of the camera.
Somebody just asked in the chat, what was the most amazing thing you ever seen through a telescope?
Probably, let's see. Most amazing thing I ever saw was when I, by hand, I tracked the ISS, and I looked at it at high power with the telescope. I actually got it in there, and I could actually see when the space shuttle was docked to it. And I had high power, and I actually got a glimpse of the actual windows on the space shuttle. I mean, that's how good I had for the seeing. It was right overhead.
Was that at an observatory, or?
No, that was actually with this telescope that I have here, but before I had it in the observatory. And I just had it out there, and I saw that thing up in the sky. I said, hey, what's that? And I just started tracking it. And I wasn't even in what's called equatorial mode, where you had the east to west axis lined up with the east to west rotation of the sun, for instance. Mm-hmm. I was in alt-azimuth, where it was just sitting straight up and down relative to where we're standing on the Earth, and I just did it that way, and followed it. And if people ever want to learn the difference between equatorial mounting and alt-azimuth mounting, the difference is alt-azimuth is really, really hard to follow something moving through the sky by hand, and equatorial is a little bit easier.
Let's see. So we got Matthew Calloway in the chat actually made a comment here. I want to get your thoughts on it. He says, black holes cannot be tested. You can't measure. You can't get close to them by any means. Therefore, black holes do not exist. That's not a question. It's a fact. What are your thoughts on that?
Well, whenever someone says it's not a question, it's a fact, they've already made up their mind. And so you don't want to bother answering or challenging them, because they don't want to potentially hear it. Matthew is free to write, if he's willing to hear it, but the bottom line is, black holes are theorized to exist, and that's true. We haven't actually seen a black hole. Why? Everybody now, they're black. We can't see them. However, what do we see? We see their interaction with the interstellar medium. We see what they do in conjunction with other objects like white dwarfs, like other black holes. We see their residue in space as gravity waves, which you talked about right at the beginning. We see all these things that are predicted to exist with black holes right there in space. But not seeing a black hole itself is sort of academic. We know going in we're not going to be able to see a black hole. We can see, for instance, at the event horizon, that's the area beyond which light can't even escape on one of these black holes, which goes back to the fact that light actually is particle nature that has mass, relativistic mass, but it has mass, okay? And so the mass of the light is such that even the mass of light is held in beyond the event horizon. Now, at the event horizon, a lot of really strange things are going on. There's a lot of physics happening there, including a lot of strange magnetic field things happening. So we can see strange emissions of radiation from event horizons. We can see what's predicted. For instance, there's predictions that we'd see some bursts of magnetic field activity, all right, at the event horizon. So they went looking for it, and they found it at the suspected black holes, all right. So to Matthew Calloway, black holes cannot be tested. That's absolutely not true. They can be, and they have been, and they've passed. Okay, they've passed our muster for finding them. We've actually predicted expected effects and found them based on the predictions. We didn't see the effects and then back into an idea about what we think they are. We predicted effects and then found the effects. So it went that way. That's actually better than predicting, for them not predicting it, but seeing it and then trying to figure out a way to explain it. So no, black holes can be tested. They have been seen in their effect on the medium, the interstellar medium.
And MM asked, did you actually see all these observations about the black holes you were talking about, or are you repeating what you've heard?
Well, I read the research papers and stuff on the black holes, especially the gravity wave. And like I said, it wasn't a collision of black holes; it was a merger of black holes that caused these gravity waves. And there is imagery out there that you can see of this area in space that actually shows these ripples of gravity waves. You can see them. And that's kind of cool. And now they look like they're not moving because the black holes are so far away. So, it's like a supernova. A supernova is moving out at thousands of, kilometers per second from the star that blew up. Yet it looks like it's just sitting there. But back in 1000 AD, when, say, the Crab Nebula blew up, okay, that is M1 in Taurus, the bull, which is a star that went supernova, and it kind of resembles a crab. When that star first blew up, it was like in 1024 AD when it blew up, and people saw it. They saw this new star in the sky for a period of a couple of weeks, and then it faded away. And of course, they couldn't do anything with it.
Right.
Then we looked in that area, and we saw this nebulous cloud in our age, 2,000 years later. And when we saw it, 1500, sorry, and when we saw this thing, we actually looked at it in the sky, and we said, "Oh wow, this was actually, just a point light back when it was viewed and exploded, and then over time it went to this that we see here." So I mean, that's part of what we talk about. I mean, it's very important to put into context that some of these things that we look at are actually thousands of years old, and are pretty interesting. And by the way, I said 1500 years. I meant 900 some odd years. I didn't mean 1500 years, like how long ago the crab went up. It happened in 1024 AD.
Right.
So that puts it at like 900 plus years, or just under 1,000 years.
I wrapped up the last stream you were on with a question that I thought we should go a little bit more in depth with, and that was, remember when I asked you what you thought was more important, going to Mars or establishing a moon base, or establishing an orbital station for stuff?
Yeah.
And I believe you said establishing a moon base, correct?
I did, because to me, I felt that we want to mine the asteroids, and the asteroids are made of the same material we see in the moon. We want to use resources like are on the moon to build and refine metals in space, in orbit, and build spacecraft in orbit. Going to Mars, is a great endeavor. It's the next frontier, only because we've been to the moon before. But I say we go back to the moon in style, baby.
You know what? Let me just question in the chat real quick, because I just want to see, as we're talking about this, how many people think. So, chat, this question is for you, and you can put in the chat, just write either Mars, moon, or orbit. One of those three options. And in your opinion, do you think that we should head towards Mars? Do you think we should put a base on the moon and start there? Or do you think we should do an orbital station where we can build stuff actually in space and take off from space? But we still have to get stuff there, obviously. Which one of the three, Mars, the moon, or an orbital station, do you think we should go towards? What is your opinion on it? And once again, Mars, moon, orbit. Just go ahead and put one of those three options in the chat, and we'll go on from there. Continue.
Is it not true that we're actually in orbit already? I mean, come on,
we
have the ISS.
Have the international. Right? I'm talking about an actual, real giant, orbital space station where you.
Okay, a space station that meets your criteria.
right, a huge criteria. Like you can actually dock, 50 ISSs onto the thing if you wanted to. I'm talking like straight out of Mass Effect.
Yeah, exactly. Hyperion.
Yeah, we got the Citadel parked in orbit.
Citadel, yeah. Yeah. So
yes, I agree with you. I believe the moon is where we should be and where we should be paying attention.
Yeah, and Moon Base Alpha. Yeah, that's great. Yeah, remember that? Remember Space 1999?
Well, the only reason I'm saying moon is because eventually helium-3 is going to become part of our, if not everyday lives. In some way, shape, or form.
No doubt. I mean, helium-3 will be important to manufacturing processes as well.
Right, so we have to get up there and get mining,
That's right. And keep in mind that for us to leave our planet and go elsewhere, I mean, yes, we are going to want to put a base on Mars. But guess what? Putting a base on Mars and putting a base on the moon are really just about the same thing, except it's harder to do it on Mars.
Yeah,
and people say, "Well, wait,
a lot farther away."
Yeah, when people say, well, Mars has an atmosphere, isn't it easier? Well, you would think so, except that the atmosphere on Mars might as well be a vacuum.
Do you think it's
You can't.
possible to terraform the moon?
The moon?
Yeah.
Um,
Say if you had all the time in the world. Okay, we're taking time out of the equation. Do you think
okay, if we
it's
took
there
the
for
time
give
out
it?
of the...
Is there a way to give it, like, say, just in theory, a way to give it a magnetic field, a way to create a atmosphere? For it? You know, you think with enough time that we would be able to figure it out?
Okay, my opinion is, and this isn't just my opinion, it's the opinion of astronomers in a lot of circles, is that the moon is not massive enough to retain an atmosphere.
Okay.
That is, if the moon ever did have any primordial atmosphere, it very quickly was lost to space. And that probably was because of the fact that the moon itself is not massive enough that its gravity could hold the atmosphere down, like Earth is massive enough to hold the atmosphere here. Right. Okay, and you notice that there's a lot of moons out there, a lot of moons around other planets in our solar system that also are airless voids on their surface. They don't have an atmosphere. Now, you get to a certain size, and some elements can be retained. Okay, Pluto retains a small atmosphere, a vestigial atmosphere, mostly nitrogen. But it's really interesting because most of Pluto's surface is nitrogen ices. So when they sublimate in the heat of the sun, that nitrogen can get trapped and stay around Pluto because Pluto is able to retain it. But again, that's due to Pluto's size. When you look at Titan's nearly the size of a planet. It's just like the size of a small planet. So Titan has a thick atmosphere of nitrogen, in fact, which is really interesting, and has other elements, of course. So it has to be a good size. Mercury, no real atmosphere to speak of, obviously. And, Venus obviously has an atmosphere 90 times denser than ours, and that atmosphere, of course, it's interesting. We look at Venus, and Venus was always thought of as a sister planet, quote unquote, to the Earth. Well, Venus is a snapshot of what we were. We had an atmosphere like Venus that was 90 times denser because when we were first formed, like Venus, we ended up having a lot of volcanic activity that spewed a lot of stuff into the atmosphere, made all kinds of toxic slurry that went airborne and stayed in the atmosphere. But then, because we're in the habitable zone around our star, we were able to have our atmosphere rain out. That is to say, we were able to have liquid water, and thus the heavy water vapor content in our atmosphere reached a critical point where the planet wasn't too hot to allow liquid water to form, and so it condensed. And when it did, it began to rain, and it rained for millions of years, solid. I mean, the weather report would be easy, another day of rain, okay, but and that actually made the oceans, along with cometary impact and stuff. People don't understand. We were hit by millions upon millions upon millions of comets in that early development because the solar system was a very, very turbulent, very, very active place, very dynamic. Just look at the moon. Okay, the moon is covered with craters. All right. Well, they came from somewhere. Those are all impacts, every single one of them, right down to the smallest ones, right up to the biggest one. The Mare Imbrium impact crater, impact location is huge, and that's basically an indicator of the size variation that we see for impactors. Well, those impactors hit the Earth too. It probably sent it into a molten state many times in its past, in its formation, and then it cooled. So once it started to rain on the planet, we got our oceans, and the oceans did something interesting. They act as a carbon sink. That means that they sucked carbon dioxide out of the air, and the carbon dioxide combined with materials in the water and formed with the rocks that are in the bottom of the ocean and formed a lot of carbonate compounds, and started a process by which the atmosphere was thinning. Around the same time as the atmosphere started to thin, and I'm not trying to go down the whole litany of history, but I'm just trying to give you a point here. When the atmosphere was thinning, that's around the time when those blue-green algae appeared, the cyanobacteria. And the cyanobacteria contributed to that and continued to thin the atmosphere. Then, this started to cause in effect, a toxic environment for those very cyanobacteria. They were actually creating an oxygenated atmosphere themselves that was to be the death of them, or change them. And they did change. They still exist today, but they're different. They've changed a little bit because they now have been naturally selected through evolution to actually be able to survive and carry on this tradition of filtering our air and doing this kind of thing. And now in our oceans, we have plankton, which generate oxygen and a life form. So, that's how this all started. But Venus couldn't do that. Venus still was too hot. And so all the water vapor in Venus's atmosphere, H2O, vapor, the sunlight that was hitting that planet, it didn't have a magnetic field to be trapped by. So it actually hit everywhere on the planet in equal doses. And so Venus was subject to the sun's direct ultraviolet energy, as was the Earth, except Earth had a magnetic field.
Speaking of the sun,
and so, yeah,
you want to? Do you have plans for tomorrow?
My oldest is graduating college, so no. No, I'm kidding. I got to go to that.
Okay. I was going to say, because I just wanted to remind the chat that we do have a solar stream tomorrow. Paul usually tries to do it around noon. So we will be taking a look at the sun. He checked it out today, and he said there was no the sun's not really that active right now.
It's sort of quiescent
and whatnot, but we are going to check it out tomorrow, weather permitting, of course. Hopefully it stays like this.
Do you have a Coronado system at all? The Coronado instrument, it's the people in chat. Coronado instrument is a instrument that allows you to see the prominences, the explosions at the edge of the sun, and the coming at you. You can see the prominences. I have one here, which I can mount on a telescope out here, which would make a really cool stream.
Lock that up, because I might throw it in my truck before I leave there.
Well, I might sell it to you because I'm thinking of getting the next step up, the actual the next Coronado that's available, which is interesting. This is the personal solar telescope.
There you go, Paul.
And it's really nice, and it has a variable filter on it, so you can actually by changing it. Now, let me explain. The sun's surface is called the photosphere that we see. Okay, it's really not a surface per se. It's actually an area that's the transition zone between the upper layer of the sun and the corona. Okay, but it looks solid to us because the sun is almost 1 million miles across. It's like 865,000 miles across. So we see it kind of solid. And when you look at it in a telescope that's using a solar filter to look at sunspots, it looks like a sharp edge. That's because it's 93 million miles away, and we can't see that it's actually a much softer transition zone to the corona than we're actually seeing. That said, and the corona, is interesting because the corona is the outer atmosphere, and the photosphere is the one you see in these solar streams, which are phenomenal. Mm-hmm. That photosphere is actually cooler than the corona. The corona is up to 1 million degrees. So you might say, well, how can what's farther out be hotter than what's more in? And the answer has to do with the interaction of the high-energy particles that are leaving the surface of the sun and going into that corona. They can actually excite those atoms in the corona to reach very, very high temperatures. Now, I told you that temperatures don't exist out in space, and that's true. However, the region of the corona is basically plasma. It's a plasma that's sort of a rarefied gas, so that you can have temperature within that. We can speak of temperature within that, and we modify the terminology a little bit. But basically, that corona can get extremely, extremely hot. And if you look just at the photosphere of the sun, we're seeing it in visible light. Now, if we look at the photosphere in a different light, say the light of hydrogen gas, which is mostly the sun, but if we look at it in hydrogen, specifically in hydrogen, we're seeing all the wavelengths when we look in the visible spectrum. If we look only at that little tiny sliver that's hydrogen, then we see something then we see something that's actually really fascinating, and it's hydrogen alpha that we're talking about. And
we should actually mention too, since there is a meteor shower coming up, you can pretty much do the same thing with meteor showers. You can tell what the components are by what color it burns in the atmosphere when it comes in. Whether it burns yellow, green, blue. You can tell what it's made of just by those colors.
And you're right. And you can actually, if you have a little diffraction grating, you can put that over your camera or over your telescope, And if you record it, you can actually see bright lines appear in your spectrum of that meteor, and that can tell you all the components if you care to investigate them. And if you have a very high quality, it's called a spectrometer. If you have a very high quality spectrometer, you can very accurately determine what each component meteor has in it. And that's cool. So with the sun, if we look at this in the hydrogen light, I was telling you the hydrogen alpha line, it's that one little thin sliver, then we can actually see tremendous detail, like the prominences coming off. So we'll work with Paul, figure something out for him. I don't use the PST, this little personal solar telescope, as much. So if he wants to use it, I can send it down to him.
Yeah, as I said, I mean, you guys will be able to chat at length when we come up there.
Yeah.
It's going to be an interesting conversation between you two, I'll tell you that.
Oh, yeah. Well,
I think me and Bill are just going to kick back and just listen and learn.
Well, you know what I might do? If I remember, and I'm sure you'll remind me, I'll bring the little PST with me. And I can hand it to him and say, here, try it out. And see if you want to do your solar streams with a H alpha telescope, here you go.
Yep.
Or give it a try,
Give it a shot. Well, you know what? Depending on what the weather's like when we get up there, you think we'll be able to do maybe a sun stream on your channel that day?
If it's clear.
Sweet.
Maybe. I mean, I can probably do it. I mean, I don't see any reason why I can't. The only thing is I'd have to figure out a way to connect the camera to that particular telescope, because right now I do not have an adapter for it.
Nice.
The advanced the next level up has an adapter.
Well, I'm bringing a duffel bag full of cords and adapters, and just in case, so make sure we have everything.
Yeah, that might be very cool.
Right.
Yep.
All right, let me skim the chat here. I know there's a bunch of questions I missed here.
Well, actually, the one guy says the dark spots in the moon are called Maria, Latin for the seas, and they're caused by volcanic eruptions. Not quite correct. They're almost correct. They're actually caused by meteor impacts that caused such disruption to the surface, such impact energy that they actually melted the surface, and so molten material from inside came out and overspread the area. So that's what the Maria were from. There are some that are the result of volcanic eruptions. Yes, that's true. But most of the Maria were actually created by crater impact.
There's last night we were looking at a crater that looked like half of it actually sunk, like a crack right down the middle, and it looked like one side was higher than the other. And the moon doesn't have what we would consider tectonic plates, right? It has no...
That's correct.
Right.
It doesn't have any of that.
So do you think that's more of a lava tube thing where, say, like a large lava tube collapsed and made it, I mean, this is a pretty big crater, too. I mean, everybody that watched last night will remember that crater with the big... At first we thought it was a shadow, but it was a big crack, with a ledge that, of course, was causing a shadow then. But it was... I mean, this crater had to be 120-some miles across.
Yeah.
And it looked like one side just caved down in and created this nice little wall that was casting a shadow on that thing. Do you think that lava tubes would be able to cause something like that?
I wish I saw it. Because I wish I saw it, because then I could discuss it and then talk about it. I didn't see it.
If Paul's listening, I'm not sure if it. I mean, it might be a different light. If he remembers where that is, that he could go in with the big scope.
Yeah.
If he's listening, I'm trying to remember.
By the way,
was.
I just want to also say to the guy that said that they were caused by volcanic eruptions. I know that's what Wikipedia is telling you, but we can't always trust Wikipedia. And when these crater impacts happen, some of these were caused by volcanoes. I'm not trying to say you were absolutely wrong, because you're not. Okay, but you just weren't entirely correct. Some of these were also caused by the fact that large crater impacts were the cause. And how you can tell? You look at the moon, and you can actually see there's large areas that are circular. Okay, these circular areas were areas where there were large impactors that caused that whole area to be molten, and that lava flowed, from the interior, flowed out. So not fully volcanic in origin. Okay, What's interesting is we don't see any of these on the dark side of the moon, which we call it dark side, but the other side of the moon from here, from what we see. We don't see any Maria there. These are only on this side. And we shouldn't see one side only with Maria, because the moon would actually have an equal number, most likely, of volcanoes that would occur. So these are due to some of the impactors, okay? And so that's what I was trying to get at before. Sorry.
You know what? To your knowledge, and this is something somebody asked me last night, and I didn't really know what to tell them because I think I heard something about it before. But to your knowledge, is there any asteroids or meteors that got caught up in, say, orbiting the moon or orbiting Earth instead of actually coming into the atmosphere, or maybe are on their way into the atmosphere by orbit? Or
well, actually, we have one now. Not to cause anyone to have fear, but there is an asteroid that is captured by the Earth in a very strange manner. It goes around the sun, and then it comes around and actually orbits the Earth once and goes around the sun again, and it's in this endless cycle. Now it's very stable, and this was actually just discovered. So we do have a captured asteroid of a sort, in our influence. And if you look it up, you can find out the name. I forget the name, because this was one of these recent discoveries, and it's very impressive because this shows that, for all we know, we find that there's something we don't know, and it's very interesting that we don't know anything, or did not know anything about this for a long, long time. And it's actually a very complex orbit, so I can't.
But you never heard of one actually getting caught in the orbit of the moon, or even if it's a small one, or is it even possible?
Well, it's hard to answer. No, not
of meteors and.
Well, that wouldn't be a meteor; it'd probably be an asteroid. Mm-hmm. Okay, and it's hard to answer in the terms you're asking. I don't know of anything like that, but in the terms that is there something caught up by the Earth or the moon? I explained there's one like that, but there's also these other asteroids. 60 degrees ahead of our orbit, and then 60 degrees behind our orbit, there's a cluster of asteroids there that are kind of in a stable neutral gravity location where they're actually going around in orbit with us. Mm-hmm. So they're not orbiting us, but they're here because of us, and the moon interaction. So. Okay. That's an interesting question. That's an interesting.
Well, somebody had asked it last night, yeah, and I thought I read something about that, like the one you were talking about that orbits us, but I wasn't quite sure the details of it. Well, we got Brandon Fisher in chat asked, Mr. D'Antonio, does the moon cause precession, or is that because of something else?
Well, actually, I think that the influence of the moon on the Earth, of course, influences our tides. And the tidal bulge, all right, is responsible in part for that precession. There's also the original impact hypothesis, where some large progenitor, that's what they call it, the thing that made the impact originally. There's a large progenitor that hit the Earth, not the moon, okay, that hit the Earth and caused the moon. And that might have disrupted our orbit. That is our axial tilt. Of that 22.5 degrees or whatever, mm-hmm. That could have been caused by that progenitor, perhaps. And then the tidal bulge created by the moon and of course the sun will exacerbate that and cause it to happen even more. And if you examine the forces on the Earth and the forces imparted by this bulge of the water and the forces from the moon. It's a very complex tugging going on all the time. Mm-hmm. And from the very beginning of time, it took some time for the Earth to stabilize into a final orbital, tilt, I should say, angular tilt. And that angular tilt is still not finalized in a sense because
And what degree is that tilt?
It's like 22 degrees, that precession mm-hmm. Is that, the Earth's tilt. And that whole mess is something that is from the original impactor that might have hit us, and or the angular momentum change from to say it this way, from like the angular momentum change from the actual global bulge from the oceans. You know.
Right. Yeah, I just want to run through some more questions in chat. I want to try to get to as many as I can. So,
sure,
shorter answers, but enough that people can understand. And Jameson here that asked a kind of a theoretical question. He says, "What if the moon is growing to look like Earth? At one point, didn't the Earth look like the moon now? Perhaps it's recovering, and in many years, the moon will settle down just like Earth, but bigger." What do you think?
To grow, it actually has to acquire material.
Right.
And
I think more or less he meant growing as in like turning into an Earth kind of growing, not actually.
Oh, like evolving?
Yeah.
Well, Earth changes because it has an atmosphere and erosion, and that's our planet. But the moon doesn't have an atmosphere.
Wouldn't that be something that's like all of a sudden, say 1,000, 2,000 years from now, all of a sudden out of nowhere the moon gets an atmosphere or a magnetic field, just out of the blue?
if somehow we could make the moon's core molten again, then the moon could generate a magnetic field if it had an inner and an outer core. See, the weird thing with the Earth is the outer core of the Earth is actually molten and the inner core is solid. Yeah. You would think it should be the other way around, but it's not.
Iron, right?
Yeah. And so under that pressure, it's solid, but the outer core is molten. And the interaction, that moving back and forth of the outer core to the inner core, that actually causes the charge to build up. And that causes a magnetic field. So we actually have a dynamo in our planet that's causing our magnetic field. And over time, the Earth's core will cool, and we will have less and less magnetic field, but not in like 10 years or a million years, probably more like another billion or 2 billion years where we'll see a noticeable difference. The magnetic field of the Earth is changing in different ways, but it's not waning on a global scale like the moon's magnetic field is gone, like Venus is gone, like Mars is gone. We don't have that coming anytime soon.
All right. And we have a question from Without Leader. Says, is the moon absorbing the daily asteroids and meteors?
It absorbs some, and there have been actually cases where people have been watching on moon launches and they see a bright flash. And that's been a meteor hitting the moon. Now, why do you see light at all? I mean,
but I will say this. Somebody, one of our guests coming up, Amy, Title, actually has a video out explaining moon flashes that aren't meteor impacts. And I think she labeled the video, what are the white flashes on the moon or something like that. And she actually goes into detail what causes it.
Did she talk about sudden geyser eruptions?
No, it was something I forget what it was. And believe me, I want to have you on when I have her on, because first of all, you guys were on a show together and probably never met. You guys were on
we were?
NASA's Unexplained Files. She was on that. She was on what was the one back in the day that was really popular? Was it Aliens on the Moon or something like that? Or
oh, she might have been on that one.
Yeah.
And see, they didn't like my answers because I wasn't giving them the one to hear.
Right, and she was the same way. She didn't get a lot of screen time, but she did, because she's more on the scientific side. She wasn't playing around with it. But she has, Amy Title has a channel here on YouTube called Vintage Space, and
right. Good channel.
She literally is an expert in all things Apollo. From any Apollo mission she knows about. She's very versed in it. She hangs out at JPL and NASA. They do a lot of stuff. She does stuff for Discovery News and of course stuff for Discovery Channel and kind of like the same thing you do. And so if you guys get a chance, check out Vintage Space. Really good channel. She gets really in depth. She gets her point across and makes it understandable to most people very easily. And she will be our guest in the coming weeks.
Okay.
She's going to come on and hang out with us. But I want to have you in here as well, because I think it would be neat to have you two talking back and forth.
Sure. I'd love to talk to her. That'd be great.
Absolutely. Let me see what we got here.
By the way, I'm always double checking myself as I'm thinking here, and as I'm sitting here looking at the moon stream, I was thinking, we were just talking about axial tilt of the Earth, and I said 22.5 degrees, and that's not true. It's 23.5 degrees. I don't know why I said 22.5.
Well,
I mean, it varies.
Now
It
you
varies
messed
over.
up. Go to the corner.
I'm sorry, but it does vary over a 40,000 year cycle. That's a whole other thing that I don't go into. But it's currently at 23.5. Okay, so not 22.5. So
there was a question actually before that last one that I missed. It says, "How did Jupiter's big red spot hurricane start and still continue?"
If we knew, we'd have the answers to life, the universe, and everything. We don't know. We don't know what caused it. We only know that over the last couple centuries, it's been getting smaller. See, and I've said before on other shows that I think that Jupiter's red spot is a transient object, something that's going to go away forever, or maybe pop up somewhere else on the planet in a different belt, a temperate belt, perhaps north temperate belt or southern temperate belt. I mean, you never know. But I think it might be a transient object, and we see this because in our lifetime, it's been reported from the 1600s, forward, from the first time people were actually viewing Jupiter. And it was much bigger and relayed as being much bigger back then than it is now. So it has shrunk in size. And over the centuries, it's shrunk. And so that means that maybe it's shrinking to the point where it's actually going away. And so Jupiter may not have a great red spot someday. Yeah, and it may very well just be a transient feature.
We're strobing again.
Yeah, he's playing with his f-stop. It seems like
a statement from a guy I don't even want to even try to pronounce that. It looks like it might be Russian or something like that. But it says, "How does Jupiter have the strongest magnetic field when it's made of gas? Where's the dynamo of molten heavy stuff in gas giants?"
Well, it has a strong radiation field for sure, and the dynamo in these bigger planets actually comes from the fact that they're so big that they are exerting tremendous pressures on the core of their interiors. And when they exert these kinds of pressures on the core of their interior, they actually do cause special conditions, shall I say, of the materials in that core. Like we talk about liquid metallic hydrogen in Jupiter's core. And we ask the question of like, well, where does that come into play? How does that affect anything? Well, it can cause some really strange, really strange effects in Jupiter. But you got to understand that a lot of the magnetosphere of Jupiter, that is the magnetic field of Jupiter, is caused by interaction with the solar charged particles hitting Jupiter. So one of the things that's happening is that liquid metallic hydrogen that we call liquid metallic hydrogen, which like screws with people's heads, okay, is a special substance that's composed of a high pressure, under pressure hydrogen. And that's the outer core of the planet, all right? Mm-hmm. Now, the inner core of that planet is not the same material. So again, we have this liquid metallic hydrogen circling around the core of this other stuff in the center, which, maybe I'm not even sure what the core of Jupiter is made of. I could, get to that. I'm going to be moving on and getting a further degree in planetary science, in fact. So when I do that, I will certainly know exactly what's composed in Jupiter's core. But I know that when that outer core is moving against that inner core, because the inner core is very complex. It's not made of one material. You can just say, it's iron. You can't say that. It's not made of just iron. Right. There's a lot of stuff in there. But as it's moving around, it's causing this magnetic field because the electric currents that are actually generated by that outer core over the inner core. And that's the same thing as on the Earth, just on a much more grandiose scale. Couple that with highly charged particles from the sun reaching Jupiter, and you get this magnetosphere of Jupiter, which also retains heavy-duty radiation. So Jupiter has its own quote-unquote Van Allen belts, okay, but they're not Van Allen belts. They're actually just radiation belts that are very, very powerful. Mm-hmm. And it's because Jupiter's magnetic field is that much more powerful, and it traps more solar energy much more powerfully. So if we ever visit Jupiter, if you expect to go to Io, the closest moon to Jupiter, well, you're going to be, bathed in this radiation. So you might say, "Oh, look, it's Io," and then you're going, and that's about all you'll see. I mean, it's going to be very, 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 very difficult to actually go there like that.
Alex, I've seen this question a couple times from you tonight. It says, P&K, any chance of us live streaming on International Space Station Pass? Yeah, we actually talked about that earlier. Actually, when myself and Paul go up to Marc's, we're actually going to try to calculate when the International Space Station will actually be crossing the moon so we can try to catch it. Even if it's not crossing the moon, we'll try to catch a pass of it either from here in Pennsylvania or down by Paul. Because obviously on Paul's scope it'd be a lot cooler. You can see it a lot more up close. But yes, we're going to try to calculate and see if we can find a way to get the ISS crossing overhead. Somebody asked, how old is this man? The one answering the questions. Marc, how old are you? Does your driver's license come on a scroll?
Yeah, you're funny. No, I'm 56 at the moment. I think I'm doing pretty good considering that 2 years ago I was a quadriplegic and blind. I think I've recovered tremendously. I had to have surgery, and during the surgery I had these blood clots that got loose from the surgical site, and I ended up having 6 full-on strokes on the operating table. And they didn't think I was going to survive, but I defied the odds, and here I am. The doctor actually couldn't believe that I was still alive, and when I walked into his office, he was stunned. Like, it's you? I was like, yeah, it's me. Shit, I thought we killed you. So,
what we got here? Oh, here's a funny one. Can you please tell me how you were doing this live? Don't you get any copyright claims? I'm not sure what we would get copyrighted for. Marc, are you copyrighted? Is the moon?
No, but the moon is. I think you're violating the moon's copyright.
When I first started, and it was before me and Paul started working together, I put up a video of the moon, and NASA copyright claimed me. And I was what?
Was it an image that you had? Was
it
an image that they took?
No, it was literally from my telescope. I recorded it. It wasn't like a live stream or anything. It was just a video I recorded through my telescope. And I just posted it on the thing, and NASA copyright claimed it. And I wrote back, I was like, since when does NASA own the moon? Well, they removed it right away. I don't know. Maybe it matched like one of their similar images on their...
It might actually have been a... because the moon looks the same in a lot of people's telescopes.
Yeah,
let's go figure.
Like, man, that's kind of shady.
Yeah, well, they certainly didn't mean it. It was probably a computer that did it. A computer doing the matching and stuff like that.
That's what it mostly is.
Or a TinEye type search. You can go to tineye.com if you have a photo. You want to find out the origin of that photo. If you think it's copyrighted, put it into TinEye, and you'll find that photos you take will show up as being flagged as copyrighted material by someone else.
Yeah.
And of course, it's not true. It's just that, it's similar,
Right. Let's see. What do we got here? Down the list. Actually, I should do shout-outs to people that have been active all night. There's been a lot of them. Let me see here. Let me see who's
I see, Amanda's been going crazy all night.
Let's look down the participant list. So, let's give a shout-out to Without Leaders and Okapla.
If you're going to do shout-outs, at least you get the name right.
Yeah, Isaiah Pelliser, I guess it is. ASAP, and BG is me, and Carmen SN, and Carmen, and Castmere, and Dang, and Dapple Ben, and Daryl, and Deidre, and Danny, which is Amanda, and then Dunster, and Dylan Allen, and Ellie.
Dumpster? Dumpster?
Dunster. D-U-N-S-T-E-R.
Dunster, okay.
Ellie, Fractured by Nature, Friday, March. Finn McFarlane, Hinduja Schmida. I'm guessing that's what that is.
That's a good way to say it.
Yeah, really trying here. I am Sci-Fi J Rich, Lone Ranger, Mikey Apple.
You're doing well.
Miss Smith, Akuma Taisho?
Akuma Matata. Yeah.
Robert Heron and Rocky and Seamus and Serge and
Bullwinkle.
TNC and Technology Tube. Ted, obviously a big supporter of the channel. Terracy, the Multiverse Traveler, the Game Guru, the Gaming FX, the Skylar PL, I guess. Tori Films, Trev. There's just so many. Vegan. Weird Guy and Zombie Nomad. That's everybody I have on the participants list. If there's more,
wow.
Shout out to you all. Obviously, there's a lot of people watching tonight.
And they all shout out back to you. I'm sure.
So,
hey, one of the things that we often talk about is the elements in our periodic table, right? And I thought I'd throw this in because when we look at the
Marc
moon,
D'Antonium.
D'Antonium. That's funny.
Yeah, D'Antonium.
That's very funny. When we talk about the elements though in the periodic table, we say, well, where did they all come from, right? Now, people know, in general, they know that a lot of the elements are created in the cores of stars, okay? But the problem is, up to the element 26, which is iron, that's the most that most normal stars can make. Beyond that, everything past that, of course, excluding the synthesized laboratory-only elements, everything past that comes from supernovas when stars explode. So the interstellar medium has seen an awful lot of supernovas because, the material that's in the Earth came from normal stars at some point or another, and supernovas. And that's something that's really fascinating to understand. And it's really interesting when you look at nucleosynthesis, that is the process by which stars generate energy. And stars are these balls of plasma, hot plasma at millions of degrees in their core, and they're hot enough to create fusion because they're massive, and the pressures from the outside atmosphere of the star pressing down on that core makes it very hot, and so they can start fusion at that certain point. Well, stars make hydrogen into helium. Most people know that. But then helium goes into carbon to nitrogen to oxygen, on the way down to iron, like in our sun. And after iron, you can't make anything past iron. There's no atomic reaction that can cause iron to be fused into anything else. So the original astronomers in the early days were wondering, where do all these elements come from? How can this be? It's because we have supernovae. And when something goes supernova, a star goes supernova, it has to be massive. When it happens, the effect is that the star is pushing out with radiation pressure all the time. And when it stops pushing out with radiation because, say, the hydrogen or the helium or the carbon or the nitrogen or the oxygen shells that are burning to make the new elements stop, the star begins to collapse. And a star like the sun will just gradually begin to collapse, and then it begins to burn something else like helium into carbon, and then it slowly starts to bloat up again and becomes a red giant. There's a star like the sun, not so massive. Okay, that bloat will fully envelop the orbit of the Earth at some point and destroy us. So that's why we have to leave the planet, number one. But then if it's a supermassive star, sometimes that nuclear fire goes out instantly. It's a very fast transition within milliseconds. And so now you have this massive gravity trying to collapse the star, this massive radiation outflow that was holding the star up. And they reach an equilibrium that's called hydrostatic equilibrium, where the star is radiating pressure out and its gravity's trying to crush it, but they're balanced, because of the forces. But when that outflow stops, these massive stars collapse, and now all that mass in the outer sides of the star, which could be 10, 20, 30, 40, 100 times bigger than our sun, rushes to the core of that star, and it hits that immutable core and just rebounds off of it, bounces off of it in a massive cataclysmic explosion. And during that explosion, pressures are reached that can forge new elements beyond iron. And that's where all these other elements come from. Now, there's actually it's pretty well understood how this all happens. And I just think it's amazing that we have so many elements in the periodic table, considering, that we have, stars only that were creating these elements. And you, me, the Earth, the Moon, all the planets, all the moons, they're all made from these elements created in other stars. And the sun itself, remember, is only 4.6 billion years old, about the same age as the Earth. And when the sun was made, it was made with additional elements that already were in the universe. So the sun has a lot of other materials in its atmosphere that it didn't make, but it was made with, when it first formed. So we see the sun as having what we call metal lines. It has a lot of lines of these chemicals that are in it that were not made in the sun, but were made elsewhere in other stars, and the sun was just formed from them. Remember, the universe has been here for 2/3 of the time, 2/3 of its existence before the Earth ever existed or the sun ever existed. So there's been plenty of time for these materials to get distributed throughout the universe. And we're humans. We cannot comprehend this, and so I think that's really fascinating. And I've been actually trying to learn the periodic table better. And so I've been actually digging in. And there's a song that I absolutely love. It's called the Periodic Table Song. Have you heard that?
I can't say I have.
No? Oh, man.
Nope.
Yeah, no, it's pretty cool. It goes like, there's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times, magnesium, aluminum, and silicon, phosphorus, then sulfur, chlorine, and argon, potassium, and calcium. That just goes on and on. And it's really, really funny.
Anybody that's just tuning in.
Yeah, that'll be pretty weird.
Oh, man.
Yeah. But the chorus is cool. And the chorus is, this is the periodic table, noble gases stable. Halogens and alkali react aggressively. The period will see new outer shells while the electrons are added moving to the right. It's really fun. When it gets near the end, you got to start saying all the really high end stuff.
Dude, that sounds like a song that I wouldn't even be able to remember. It's because there's so much involved with it.
Well, there is a lot involved. It's kind of cool because you're actually saying every element in the periodic table in the song, and it's the can. It's really funny.
Yeah.
Iron is the 26th, and cobalt, nickel, coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film. While krypton helps light up your room, rubidium, and strontium, deuterium, and zirconium. Yeah.
It reminds me of the alien doctor in Mass Effect. What's it, Morton Solus? When he was sitting around. Sheila Kelly asked, I wonder why tonight I can only see about half the moon when I look at the night sky, but when you pan out in the telescope, you can see the entire moon. Well, you can't really see the entire moon. We're only lit about, what is it tonight? About 80%, 85%?
Yeah, it's like a waxing, meaning increasing in size, gibbous, right? It's just past gibbous and heading toward full.
Right.
Astronomer's bane. Astronomers don't like full moons.
I'm not sure. Yeah, full moons are horrible for viewing.
Yeah, there's no contrast.
Yeah. Sometimes Paul does pretty good and gets the edges. We maybe see some edge craters and whatnot. But besides that, full moons are just, especially when people go, hey, you're streaming the supermoon. And they're the videos that get the most views, of course, because it's supermoon. But it's the most horrible moon to shoot through. Unless you're doing like a complete wide field, full shot. That's the only way. You're not going to zoom in on any craters or anything.
Yeah.
So
it's
I'm
all
not sure why you're seeing a half moon. I'm not sure where you are either, but I'm not sure.
Well, if she's referring to most of it being, it's off the top of the screen, off the bottom of the screen. Yeah. It's just zoomed in a little bit. He could zoom out, obviously, and people would see the whole gibbous moon.
She says she can see half the moon when she looks at the night sky. So when she goes out and looks at the night sky, but when we pan out with the telescope, you can see the entire moon. Well, once again, you can't see the entire moon, but you can see what is lit by the sun. So I'm not sure about that. Let me go down the list here. Any other questions? This has been fun tonight.
Yeah. I'm seeing all kinds of periodic table questions now.
You can always tell it's been a good night where we made a lot of people mad when there's over 50 dislikes.
Oh, really?
Oh, yeah. Yeah, but look at the chat coming through. We almost got, what is it, 260 likes, so.
Yeah.
They're representing. Yeah, you got your flat earthers that'll come in and dislike, and you get the people that are banned, and once they realize they're banned, they'll down. But, when they come in and say something stupid.
Yeah, well, a lot of people just they don't tolerate science. They don't want to hear it because, they've made up their mind.
Yep.
And
some people get mad. It's like, why are you banning us if we're, they're just expressing their opinion? We don't really ban people for expressing their opinion. We ban people that just come in and go, the earth is flat. and they just keep repeating the same thing.
Yeah, right.
Over and
then
over
they get,
again.
like,
And it's like you're not contributing anything to the conversation, you know. And then once they do try to tell you some scientific thing and you debunk that, then they don't want to believe you. So,
Yeah.
and then they just want to argue, and it's just not worth it. So that's why
Jay-
we get rid of the flat earthers pretty quick.
Jay Rich says, "Oh no, that song's stuck in my head." Ha ha.
Right. I did send a message to Bill. I know he's producing KGRA tonight, but I sent a message to him if he wanted to join us to let me know. So I'm maybe he went to bed already, but I'm looking because you know what's crazy? I stopped the chat where there's a good question, and I don't move it again until I get the question out, and then I try to scroll down, and it automatically, because you know how it gives you that little blue button on the bottom. Well, I don't touch that. I go to just scroll down so I can see the other questions, but even when I just scroll down, it shoots all the way to the bottom.
Yeah.
So I miss everything. And that's
as
how
soon
I
as someone
miss
writes
questions.
a new question, as soon as you start moving it, goes down.
Yeah.
Jay Rich said, "Can I buy a CD of you singing that song?" No, Jay. I'm sorry. It's not going to happen.
Real quick. Why can't we see the moon landing? Why can't we see the Apollo sites? Real quick.
Well, because the resolution of the cameras are nowhere near what we need to do to see them. I mean, you can see them from the lunar orbiter cameras, and those are, like 60 miles above the moon or whatever, and you can actually see them then. And then they're still very small, but you can still see them. You can see the tracks of the rovers, and you can see the descent stage of the lunar modules on there, on the moon, and all the different sites. So, it would have to be such an amazing job of fakery over the last 50 years, right, to make this all, I just don't believe it.
Yeah, but hey, you know what? The one thing I like about it is people are challenging science to maybe get a better understanding, and that's one thing I do like because it actually makes them, our science have to hold up to scrutiny, and 95% of the time it does. There still are a lot of stuff that's theorized in science, but what is theorized, like gravity and whatnot, all signs point to that being the case. Now, obviously, we'll learn more in the future, but it's when it becomes a universally accepted method, then you kind of want to stick to what you know.
Yep, that's right. That's right. And that's the problem. Unfortunately, if you just stick to pure science, then it's you don't allow yourself to speculate.
Right.
I kind of break the mold a little bit. I do pure science, but I also speculate, and that kind of gets people at both sides angry because the academia doesn't like it when you speculate, and my feeling is, well, I care, but I don't care. I mean, I think if we don't speculate, then we can't grow.
Isn't speculation what drives science to begin with? Like you speculating about how a certain thing works, or how things were made, or how things formed, and then what you want to do is try to prove that speculation.
Yes, that was my whole point with it was, speculation, okay, really can be considered hypothesis. I think that for instance, hydrogen in stars maybe I think it's being made into helium, but if we take a certain isotope of hydrogen, if we take deuterium, I think through this process we can actually make helium. Let's test this theory. Let's go look for the helium content in the star. Let's look for the helium lines in our star and see if it matches what we suspect it should be. Mm-hmm. Oh, look, it does, or it's close enough. That's pretty good. So now, the hypothesis is tested and proven, and thus it becomes theory. It becomes working theory, and then it becomes factual. And that's what's, you have to speculate first. And speculation, I think, is the first step. How do you think the moon craters form? Well, let me think. Impacts, maybe a big giant rocks from space, and then of course, Thag think rocks from space hit moon. Ha ha ha! Stupid Thag. But of course, now we know that that's true. So you speculate first. Yep.
Yeah. And Dang had a question. I think we talked about this last time, but once again, real quick, he just made this statement in chat, and I think we talked about this last time, which is why I want you to hit on it. He says, if Jupiter was a little larger, it might just be a brown star.
Yeah, we want to define that too. I mean,
Right.
by brown star, what we really mean there is that Jupiter would be what we call a brown dwarf. Um, and people say, well, is that a, quote, failed star, unquote? And I say, no, it's not a failed star in the same way that Earth isn't a failed super Earth. Earth is what it is. Jupiter is what it is. And that's how much mass there was available to make Jupiter. That's how much mass available to make Earth. So Jupiter has to be, and you know this too, about 80 times bigger than it is, more massive, 80
Right.
times more massive, to be even considered the smallest of stars. So as big as Jupiter is, it's not really ever considered by astronomers. We never thought of this as a failed star or a near star. It's not a near miss with a star. It's actually a perfect hit with a gas giant.
There you go.
You know?
And let's see, we have Mark in chat, spelled the same way your name is, Mark.
Yeah, I saw that. Yeah.
He says if the moon moved closer than a couple of its own cross sections away from Earth, if it moves over the Roche limit, will it break apart?
Well, yeah. Then let's define the Roche limit. The Roche limit is that limit beyond which, or within, at which, the forces imparted by the gravity of the parent planet would be so much on the near side of the planet that it would tend to pull the planet beyond its ability to withstand being tugged to pieces, pulled apart. So yes, if the moon moved within the Roche limit, it could very well break apart, and that's why we have a Roche limit. Perhaps that's what happened to the planet that used to be the rings around Saturn, if that's how it formed,
Right.
if that's how the rings formed. It's possible that that there was a moon around Saturn that was at some point in its evolution started to spiral closer to the planet. Why? Because as these other moons go around Saturn, they interact with each other gravitationally, and there might have been a situation where the orbital speed of one particular moon that used to be there was diminished by the constant passage of another moon. It would tug it just enough to retard it in its orbit just enough so it would get closer to Saturn. And by retarding it in its orbit, I mean slow it down. And when you slow it down, you end up dropping closer to the planet. Just like in Earth orbit, if you slow down your velocity, like hit your retro rockets and slow down, you would start re-entering your Earth's atmosphere. In the same way, a moon around Saturn of big enough size that was being retarded by other gravitational perturbation of the other moons may slow it down enough to actually fall within that Roche limit. It would be really interesting to watch that breakup take place. It would have been cool if that's how the rings formed. It could also be that the rings formed from the leftover material that never made it into becoming a moon around Saturn, and that's why we have the moons in there. There's no other moons within the ring system other than shepherd moons inside the inside the ring system. The little tiny moonlets that actually help that create the interesting artifacts we see in the rings. And other than that, we don't see actual round planet, moon-sized planetoids within the ring systems. We can't, because that'd be within that limit, and that's how it actually works.
And I do want to tell the chat to stay tuned, because I think Paul has a little surprise for you here in a little bit. So, just going to throw that out.
What time is
there.
it? Oh, it's
Keep your mouth shut, Mark.
Oh, come on. Now I know what he's going to do, I think.
But, yeah, we did this
Cool.
last time on the other one.
As long as it's good enough.
Yeah, I mean, it's still going to be low in the sky, obviously. But
Hey, don't give it away.
Hey,
Yeah.
we're talking about
I'll sing the
Halley's.
periodic table song again.
We're talking about Halley's. Halley's
Yeah,
Comet.
okay. Yeah, a few more years for that.
Mark D'Antonio, is it true that gold and platinum can only be created in a neutron star mergers and not supernovae?
I don't know the answer to that question, because I believe that gold and platinum in particular could be created in super heavy stars anyway. But there's the fact that a neutron star has a surface with this degenerate material on its surface shows that material never left the neutron star. So the fact that we have gold and platinum in our crust shows that some material from these supernovas got to us. So that can't be entirely true. So I'm sure that there's gold and platinum here because of supernovas. Right. So it had to get here because there's no other way. I mean, neutron stars don't just like blow up; they're the result of that. And what's left over doesn't ever, explode again. Although I will say, you can get on like a white dwarf, which is where the sun will end up eventually, in a binary system. The main star, say there's two stars. One star bloats into a red giant because it runs out of its fuel and starts burning other things, and thus temporarily bloats up, and then it shrinks down. Not massive, but a smaller star like our sun goes to this white dwarf stage. Now that white dwarf is very hot, still has nuclear fires burning on its surface, but it's actually doing different processes. But then the main star could be feeding it material over periods of time, and that material spirals around. It's called an accretion disk, a disk-like structure around that white dwarf, falling on its surface eventually. And sometimes, when that material builds up to a certain level, there can be a spontaneous explosion off of that white dwarf, and that we call a nova. That's a nova. And that nova will also send out some material into space, but it's not that type of material like we see on a neutron star. It's very different.
I want to ask this question from the Gaming FX because he posted it like 4 or 5 times, so I want to make sure it gets answered. But once again, real quick, what would happen if Pluto crashed into our moon? How would it affect us?
Well, obviously,
I'm guessing take out the thing that Pluto's way far away, and the possibility, obviously. But what happens if, say, something Pluto or Pluto's size hits the moon? How does that affect Earth or us in general?
Well, a number of things would happen right away. I mean, we would actually end up seeing major changes to the Earth almost immediately. Now, Pluto's size is, it's small. Okay, it has a radius of like 1,500 miles or so. So it's not that big, but if it was big enough to hit the moon, then we have to say, well, at what speed, whatever. But let's say in the worst case, Pluto impacting the moon at a high rate of speed would probably cause a significant portion of the moon to vaporize instantly and get thrown into space. That would immediately be sent away from the moon. Some of it would be captured by the Earth, and the Earth would then be pelted with tremendous number of meteors from this impact, perhaps for 500 to 1,000 years. As these things would just keep coming back into the Earth's atmosphere. That could cause two things. That could cause a superheating effect on the Earth, superheating of the Earth's atmosphere, which could literally make the atmosphere incandescent on the Earth. And that's kind of fatal to life. But
not to mention one hell of an asteroid belt.
Yeah, if you were to survive, oh look, an asteroid belt. Oh, we're going. But yeah, so it would definitely be a major impact. Now, Pluto is dense enough so that it would cause this major problem. It's not made of feathers. It's actually made of a lot of nitrogen. There's rocky core. So it would actually do significant damage,
Absolutely.
Yeah.
And we did have, let's see, I just want to make sure I'm getting everybody here. Of course, I hit down, scroll, and it scrolled all the way to the bottom again.
Yeah, I don't think you'll hit everybody here.
Once again, we're gonna keep the answers short, but definitely.
I'm trying.
Just because I want to try to get to everybody. Because you're still good, right?
Yeah, I'm fine.
Time wise, okay.
I want to see Paul's surprise.
If so, he said it's still a little bit down past the building yet. So I mean,
yeah,
I might as well give it. I mean, he's thinking about going to Saturn, but as of right now, it's not looking like too good. He said even Jupiter's not looking too good right now because of the atmosphere, and that one's behind the building. So there's no guarantee that that'll happen. But
we can look inside the office building,
right? But in about 10 minutes or so, we will take another short break. So we can refill drinks or whatever, and But let me see here. We got. Does the moon affect the stock market? Yes, it does. People shop more on full moons.
Actually, that's a sensible question. It does affect people, and that's the psychological effects on people are not documented medically, other than to say that it's psychological and not physical.
Right.
So it's pretty cool.
Mike Baseman asked, my mom wants to know if any life can live on the moon. I think it can live on the moon. It just has to have something to live in to make conditions.
Yeah, I mean, let's consider that we did find microbes in the outside of the ISS. And they were microbes that we may have contaminated it with, but still they were alive and found on the outside. I think that's interesting because that implies that our science isn't perfect. We don't have all the answers. And could there be life on the moon? Well, we have to go back to the evolution of the moon and look back at the origins. And my feeling is that if we consider that the moon has been here for 4.6 billion years, just about, a little less than that because it was made shortly after the Earth was made, then we would consider that life took 4.6 billion years to reach our stage. But at 3.8 billion years ago or so, we had microbial life on the Earth already, and maybe even earlier in some of the research. And so if that's possible, you have to say, well, why did it happen? Well, it happened because the Earth is in that habitable zone. Well, the moon's in the habitable zone too, isn't it? Because it's surrounding the Earth. But the Earth also has an atmosphere. It also has a magnetic field. The magnetic field is very important because ultraviolet radiation will otherwise sterilize the ground. So it's possible that any creatures that might survive on the moon would probably have to be, if they survived at all, inside the ices that are in the permanent shadow of the craters. That there are some craters that never see the light of the sun, and in that permanent shadow there is water in that lunar soil. The L-Cross mission proved that.
For a moon base, their prime areas is on the South Pole, right?
Well, their prime area
we're going to put one there.
Yeah, the prime area is where there's craters that are in permanent darkness that might have water content in the crust. Water's the most important thing. The rest of the moon is primarily arid.
Right.
Okay, but in the craters, there's actually, as L-Cross showed, the L-Cross mission showed that there was some of the water vapor actually that was generated by the impact.
And the people that don't know, the L-Cross mission was where they intentionally they crashed a satellite into the
they crashed a rocket booster into the moon crater into the shadow,
right.
To see if they could detect spectroscopically any water vapor in that result. And so
you can watch that footage on NASA's website too if you want to see it.
Yeah, and people are curious why you see a bright light when things hit the moon. Well, that's what's called transfer of energy. As soon as something that's moving fast hits something that's not moving fast, it generates a lot of friction and a lot of heat. And a lot of heat generates a lot of light, and that light is what people see. The melting, the instantaneous vaporization is actually a very bright process. Even in a vacuum, you can see that a bright, a vaporization effect, and that happens. Because when that stuff is going up in the air, that's a sort of a rarefied little atmosphere it's created, where there's enough density that you see that visually, and then it just goes away rather rapidly.
And Stephen Smith writes, if a solar flare was ejected big enough to hit the Earth and Moon, would it wipe out all humans, or would some survive, and what effect would the flare have on the Moon, if any?
Well, during the Apollo missions, as what's her name now? Was it Cheryl? What's that woman, the Apollo specialist?
Amy.
Amy, my gosh, yeah.
Amy Shira Title.
Oh, okay. Well, Amy will know, of course, that the Apollo missions, they were very, very careful to look at solar cycles before they sent the missions up there, because they knew that any radiation, any outburst from the sun, could be deadly to the astronauts.
And there actually was some that hit and actually knocked out some components of some of the Apollo missions.
Yeah. And so, because they're fully exposed up there, and their spacesuits don't protect against high energy ultraviolet rays and charged particles from the sun. They don't get protected from that. So now, if we had such a flare hit the Earth, then it might do what happened in 1965, which was human error at that time. That was the Great Blackout of 1965. That was human error for that one. But in the 1980s, like 1989 was it? There was the massive blackout starting in Quebec, where the power grid was overloaded, and that was because of a massive solar flare that hit the Earth's atmosphere. And we do have a magnetic field. However, Quebec's kind of north, and the charged particles spiraled down, and they were so voluminous that so much volume of charge was in this burst. It was a coronal mass injection, a CME. And when it hit the Earth's atmosphere, it totally overloaded it. And it actually caused power grids in Quebec and relays to fail. That trickled to all the other places down the eastern seaboard, and there was a huge New England blackout caused by the sun. Right? And we have our very frail electrical grid on the surface of our planet. Mm-hmm. So it's like, wow. I mean, it's like, I could have had a V8. You pound your head and say, I could have had an underground electrical grid. Right. That was protected and shielded. But we didn't. And so what happened was we ended up having a power outage that was potentially $30 billion a day in recovery. Because another thing that happens is, as soon as these charged particles hit the atmosphere, what happens to the atmosphere? The atmosphere gets heated up, and when it gets heated up, what happens? It expands. Mm-hmm. So satellites in low Earth orbit were now having degraded orbits because they're hitting more atmosphere. Yep. And those satellites all had to be boosted, and that cost huge amounts of money. And it took weeks to recover from that blackout. Now, we saw auroras, and here in Connecticut, where I live, I actually saw auroras, and they were coming in directly over my head.
And you know what? They were just north of here, where they were up in the mountains of Pennsylvania, but not quite down here low enough. I was hoping.
Well, actually, people saw auroras down in Cuba from this event in the 1980s.
Oh, okay? You're talking about that? I'm talking about one a couple of years ago.
Oh, no, I'm talking about 1989, the massive one. Yeah, no, and I called the alert network, and gave my report that explained, okay, we got a flare radiant impact from the flare directly overhead in Connecticut at 41.3 degrees latitude and 73.5 degrees longitude. So as I reported the radiant, and because we looked over your head, it looked like you were staring into a time warp or a space warp screen. The entire area over your head was streaming out to the sides, all sides from the central point. So it looked like you were moving at this high speed through space. It was just awesome. And I was actually watching the movie The Dark Crystal at the time, and this was at a drive-in, all right? So I'm standing outside my truck, okay, looking up going, wow, this is so cool. And everyone's getting out of their cars and looking up going, oh, man, it's the end of the world. And they go, no, it's a cool aurora. And it had like a little science lesson right there.
And all the old people are like, are these guys high? What's wrong with them?
Actually, that day, everybody out of their cars was looking at the sky. And as soon as I started talking, I sort of attracted a crowd. It wasn't intentional, and I just started telling them, this is the radiant. This is where the stuff's coming in. Mm. These are highly charged particles. Those green, that's nitrogen and oxygen, and the red is nitrogen. And then by the end of that night, by 3 a.m., I wasn't there anymore. I had gone home. At 3 a.m., I went outside to see what status it was, and the entire sky, horizon to horizon, on all sides, was pink, bright pink. It was nighttime now. There were no stars visible. It was like that Star Trek episode, For the World is Hollow and I Have Touched the Sky, where it looked like just a salmon-colored pink, from horizon to horizon. And it was the oddest thing I've ever seen in my life. Very cool.
Very cool. And on that note, guys, we are going to take a break just for a couple minutes. we will be back on, and in this next section of chat, we're going to talk about what everybody seems to want to talk about. And we're going to talk about aliens and spacecraft and possibilities and personal beliefs when it comes to extraterrestrials. So we will
that'll
cover.
be fun.
Yeah. So in our next segment, right after this little break, we'll get to tackling that. So I'm definitely interested to see you guys' questions on that subject, and we will be back in a couple minutes. So guys, just hang tight. Once again, Paul is on a little bit of a break himself, getting something to eat. So once he comes back, we'll be good to start zooming again. All right, guys, we'll be back. There we go. And then the lady said, "That was a disaster."
Oh, she backed into the fan.
She backed into the fan.
Oh, that's funny.
What a dummy.
Oh,
Anyway.
wait, we're live.
Oh, shit. Ladies and gentlemen, it's Rush Limbaugh's 22nd hour of the
EIB Network. EIB.
We're starting to get loopy, and we're going to be talking about aliens. Ladies and gentlemen, welcome to Alien Talk.
Actually, Amanda sent me something that I just want to mention real quick. She said, "Have I seen this?" And it was about the what's called the R process in neutron stars, and it was a way to generate platinum, uranium, or gold. They are what this article, which was in astrophysics in one of the journals, is talking about the processes by which a neutron star may be a promising way in which these heavier elements can be formed. It doesn't mean it's the only way they're formed, so we just got to be careful about that. Now, the understanding of the processes are changing over time. So some of what we know may change, but that's actually very interesting. So I just thought I'd throw that in.
Heard it here first, folks, on the EIB network.
You better drink some coffee, buddy.
Yeah, I know. Tell me about it. Time for a peanut butter jelly sandwich. All right.
There you go. And, about these aliens, when we're talking about alien life, I'm wondering, when we talk about that, is there a possibility that people would be interested in learning or thinking, as we do, speculating as to what life may have been like on Earth had certain things not happened? Life was nearly destroyed 5 different times on this planet to a variety of degrees. And that altered our evolution, clearly, because each extinction on this planet created gigantic holes in the evolutionary tracks that were available, and it ended genetic lines of thousands of species. Right. And new species came along and mutated and formed and filled those adaptive roles that they could adapt to. And so what does that mean? What does that mean for us? And we look exactly the way we do because of that exact lineage that occurred here. That doesn't mean that every creature is going to, in the universe would ever be like us. But I do have an interesting theory that I will spring on everybody, and that is, I believe that the universe does promote symmetry. Every animal on this planet has symmetry. Every vertebrate has symmetry about its central axis, right? 2 eyes, 2 ears, two forelegs, 2 rear legs, but it's symmetric.
A mirror copy, one side or the other.
Yes, yep. But that's symmetry that is enforced across all of the animal kingdom, all of the insect kingdom, save the creatures that are specialty creatures that evolve a different way, which of course we could find out there, and I totally buy that. But think about it as a possibility that the universe provides a template for life in the universe, and that template includes symmetry. May not be enforced for all life forms, but for all life forms that developed here on this planet, surrounding a relatively normal star and a relatively normal planet with water, inhabitable zone, symmetry was enforced all throughout the evolutionary tracks. That means something, and we can't ignore that.
So you mean that most likely there's no such thing as like Cyclops?
There may be animals that have only one eye. There's animals that have no eyes. Some cave dwellers and deep ocean dwellers have no eyes. But they're symmetric, in that they have areas where their eyes were, right? But keep in mind that we only have one liver, we only have one spleen. It's symmetry on these macro factors that make up these bodies. But then the reason we only have one liver is because only one liver is necessary for us to do what we had to do. as creatures. So I think that symmetry is very important. That has something to do with this. Right now, the next thing is carbon-based life. Everywhere we look in our solar system and around other stars, we see amino acids and carbon-based compounds, hydrocarbons, the basis of life as we know it. Now, we have to be very careful because we are the only template we have, and we are the only template we can see. We don't know of any other templates for life. So we could potentially overlook other templates because, well, we see water trapped on Titan that's hard as granite. And here on Earth, water that's frozen, that's hard as granite, and it is at such a low temperature, we would not expect life like can form here can be there. I mean, yet it's possible that there is a life form that could exist in that situation. We just haven't found it yet because we are not open to finding it. Right. So those are my theories about the symmetry and the hydrocarbons being everywhere we look.
Let me take you down the rabbit hole for a second.
Let's go.
Do you think there is a chance or any kind of possibility that modern civilization has existed before? And I've seen people bring this up, that maybe we were as advanced as we are now say a million years ago, but something wiped us out. Some kind of cataclysm, whatever. And that all this happened before, and this is basically our second shot at it, or our third shot, or our fourth shot at it, to finally get to the finish line. What that finish line is, nobody seems to know. But do you think that there's a chance that all this has happened before? Not exactly the same way, obviously, but when it comes to technology, when it comes to the advancement of man, do you think it's a possibility?
Well, I mean, do I think it's a possibility? I think that there is a possibility that there could have been a civilization that did advance but then was wiped out. There's always been rumors of, Atlantis in this rabbit hole we're in. There's been rumors of the Sumerian culture being far more advanced. And so it's as a science person, I can't say that it's impossible.
I'm not talking from a science perspective. I'm talking about personal perspective. Just you yourself.
Yeah, me myself, I tend to think that there may have been advanced species here that are no longer here, and that may have originated here. But it's almost like I don't want to kind of admit that publicly.
Yeah,
because it's not that I'm afraid of any kind of ridicule or not. I take full responsibility for everything I say.
Right, because you're a person scientifically, and you want.
Yes, and so, but from the background from my background, that generates part of what I feel. So by thinking about this in that term, I'd have to say that there's a couple factors that would, set me against that. First of all, you look at the evolution of plate tectonics on our planet. I mean, any kind of society that would have to develop would have to leave no trace of itself. How could that be? Well, that could be if the society that developed was near a subduction zone. What's that mean? That's where two plates, tectonic plates, are located. But the subduction zone is where that plate is diving under, where one plate's diving under another. So what was on that plate is now lost forever as it goes underneath the tectonic plate. Right. Now, the Mid-Atlantic spreading ridge, is in our Mid-Atlantic Ocean, and it's spreading a few centimeters a year. At the other end, out in the Pacific Ocean, there's a subduction zone. That's where that North American plate's diving under the Pacific plate. Okay, that event. Okay, if there was some society there at some point that was located there, they could theoretically have been subsumed into the Earth's mantle over time, and any evidence of their existence wiped out. But I think that from what we see in the fossil record, from what we see elsewhere, it's probably likely that no real society like that ever really existed.
So if I'm reading you right, you're saying it is a possibility, but not a likelihood.
Exactly. That's a good. I could have just said that first and eliminated all the stuff in between, I guess.
You have a question from LZ in the chat. It says, "Oh, here we go. You're gonna love this one."
Maybe I will.
Our good friend. All right. What can you say on John Lear's claims that there's an atmosphere on the moon equal to being such as the peak of Mount Everest?
70%
of the Earth's. Let's talk about Mr. Lear, shall we?
Well, when I talked to John a few weeks ago, he was telling me that he thinks there's seven civilizations living inside the sun.
Mm-hmm.
And after my eyebrow stopped twitching, I said, "Say what?" And he says, "Well, I want to say all these things before I'm no longer able to say them." I'm like, "You want to totally destroy yourself before you pass away or something?" I mean, I didn't say that to him, but I'm thinking he's saying things that are patently unprovable and very, very, very highly unlikely to be the most generous in the terminology. It is highly unlikely that any such thing could ever have been the case. And I don't think that's true. And so he was saying, like, he was adding these, like, 2 or 3 a day. He was posting these crazy possibilities.
That. And my biggest problem with it was that the only proof he could give for it is to ask somebody else. Like, ask somebody he knew that did this, or ask somebody, and it's like, okay, well, when we do that, what's their proof? And it's just, once again, hearsay. There's no actual proof of it. And it's like, John, I mean, obviously, major respect for John Lear, major respect for what his father accomplished, with the Lear jets and everything. And he's a respected pilot. But when you start going down this hole, it's a perfect example of somebody going down this rabbit hole and then all of a sudden buying into it and then just keep spiraling to the point. Like, if you would have talked to John Lear 20 years ago, he was in on the alien UFO stuff, Area 51. Fine, a lot of people were investigating that. But when you start saying that there's 7 civilizations living inside the sun, that is just taking it to a whole other level.
Yeah, and I respected John Lear for many years. I thought he was really good, but when he started doing this stuff, I asked him for proof. I said, "John, I'm willing to look at your option. I'm willing to look at what you're saying here, but offer me some proof." And he would say, "Well, go watch this video by this guy." I go, "No, John, watch this video on YouTube by some guy. He really didn't watch a video. I mean, I want you to show me scientific results. Is there someone that's done a study? Is there someone that did a research project where there's actual data, or are you just saying what someone else thinks?" I had attended a conference in Los Angeles shortly after I learned how to walk again 2 years ago. I actually made it my goal to be in Los Angeles to speak at a conference, and I spoke at the Mutual UFO Network conference, and I did a talk on exoplanets. And I'm trying to remember where I was going with this. Holy crap! Help me out. Where was I going? My mind is.
We were at
I'm
John
sorry,
Lear.
Dave. I'm afraid you can't remember that. It's almost like that for me.
Mark, please open the bay doors.
So I was going down the path here. Okay, I know I'm tired, so maybe that's part of this.
It's been a long stream. I mean, we've been on for 5 hours already?
Keith's going.
Yeah, no, I'm
Hello?
here.
Oh, okay.
No, I was just looking at the thing. I was like, man, we've been going for what? Like, going on for 5 hours already? Something like that?
No way. Really?
Well, I think we had the first hour without you, right?
Yeah. I'm trying to remember where I was going with that. I wanted to make sure I get that point.
We were pretty much saying that John Lear was crazy.
Yeah, but I was trying to relate it to having to do the talk. But I can't remember where I was going with that. But it was a really good point too, man. I'm sorry, folks. It's 10 of 2 in the morning here on the East Coast. I'll
tell you what. If it comes back to you, but you can answer Amanda's question in chat right now. How about that?
Okay, and what is your question?
And her is, how often do people with brilliant ideas go too far with theories and get written off as crazy? Examples, Lear and David Icke.
Well, you know what? In the UFO field, I find that it's all too
Way
often,
too
you know.
many, yep.
And I think that the hard part, for people in the UFO field is when the attention stops. They, for me, I don't care. I mean, I don't care who says it as long as it gets said. And I'm going to do this for the rest of my life. I mean, this is my passion. This is my calling to do this kind of stuff. But I do feel that sometimes people who may have otherwise had an actual sighting and had actually been involved and had something happen like that to them, where there was a real event. I think sometimes if the gravy train stops and the intention stops, they feel the need to embellish it. Now, Stan Romanek's a good example. Stan was, he seemed like a good guy. He seemed like an upstanding guy. But when I watched his alien video, I immediately had questions. And I immediately felt like this doesn't sound right. And when I watched the video, I said, that video doesn't look right to me. It looks like a puppet. That doesn't look right. It looks like a head on a stick is what it looked like. And when I had someone else go out to the house where this supposedly occurred, the area that the alien supposedly came up into the window from, it was a window that was really close to the porch. So the alien would have had to have been like 12 inches tall,
right,
with a gigantic head or something. It was really, everything was wrong about it. So
it almost had that staged feel to it,
It did, and then he jumps, woohoo! Like he did a cartoon jump, like cartoon characters do when they're excitable. Whoa! And they jump in the air and then run. I mean, he did everything but let his feet run in place for a while before he actually started to move. Yeah. And I had to laugh when I saw this, and I was like, this just didn't look right to me. So I kept an eye on him, and I kept going, and I listened to him do an interview with Alejandro Rojas, my good friend, for Open Minds, and when he's doing this interview, Alejandro is doing a public service announcement, and I hear, and this is to answer your question, Amanda, I'm hearing in the background this weird voice that's going, you should really, and it's like, what's that? And I know what it was. But 6 minutes later, I found out, because in the middle of Alejandro talking to Stan, all of a sudden you hear in this computerized voice, like I heard during the PSA, the public service announcement that Alejandro was doing, I hear this, you should really learn how to keep your mouth shut. And Stan goes, wow, what was that? And Alejandro says, was somebody interrupting our interview? And Stan's like, I have no idea what that is, when in fact you could hear Stan doing it during the public service announcement. He was actually testing the equipment, thinking that his mic was off. Right. All right, so that was the first one. I was like, okay, what's that? Then he did a video interview with this Australian guy who, bought him hook, line, and sinker. And he did a Skype interview, and he had the camera set up so that you could see his left hand and his right hand. But his view of himself on the screen was small, and he didn't see that his hands were visible. He couldn't see that. So halfway into the interview, he has a USB drive in his left hand, and in his right hand he has a pen, ordinary pen. Keep in mind, both these things are handheld objects that you put in your hands. Halfway into the interview, you see him fling the pen at himself, and it hits him in the face. And he looks around, looks up in the air like it came from above, and he starts, very stiffly looking around. And the Australian guy goes, Stan, what was that? Was that like some paranormal event taking place? Yeah. And he goes, I have no idea what that was.
And you know what's a shame? That he might have had a legit experience.
That's
but
right.
Just by making these attempts, it just totally denies everything he's ever done.
Puts everything into question he's ever done. The full body of work, right?
The way I put it is pretty much, it's the same thing happened to Billy Meyer. Billy Meyer
I was going to mention him next, yeah.
Had legit, stuff and proof, and then sometime after he did the interviews back in the 80s with the Cowboys and Dr. What was his name? The guy that went and interviewed him for the first time, what I'm talking about.
Yeah,
And
I know that.
It was a very interesting case. And then all of a sudden, once it got popular and people started hearing about it, all of a sudden, then you start having the wedding cake UFO show up, and then you start having all these things that people could actually go out there and prove that could be faked, easily faked.
I showed proof that the wedding cake UFO was fake.
Well, not only that, but his wife saw his ex-wife saw one of the pictures and said, "That's our old trash can lid."
Yeah, and in fact, a guy went to the farm and photographed the trash can. It was actually a storage barrel lid, and showed the wedding cake UFO and the storage barrel lid. They were literally identical. How did Meyer respond to that? Well, the aliens make their ships in familiar forms that we can understand. Right. Good try, Billy.
And then when you start, then you start like almost a cult thing where they pay memberships and people living and working on it. And it's like, that right there just took everything that may have actually happened and just totally, wiped your ass with it.
Yep. Yep. And that's what I think Stephen Greer is doing right now.
I will agree with you 100%.
I wrote a big thing on Facebook, and a lot of people saw it. And I've found Greer to be very dishonest, and I've found him and a lot of people that are listening right now might not think this is true of him, but I've been following the guy, and I can tell you that he's done some things that are really untoward. They're not. They're like, for instance, in Vero Beach, Florida, there was a military exercise going on offshore, and they were dropping flares. This is documented. Everybody knows it happened. It was documented. Well, they saw the flares from the beach, and Greer knew they were flares. And I'll tell you why. He said to the people watching, "Oh, these are alien beings. Welcome them into your hearts." And then he said, "These are not flares. These are not flares." Doing the group think thing, trying to make sure that he instills in their mind that these are not flares.
Right.
And if they like him enough, they will listen to him if they trust him enough. And that's what he was trying to do. And I would often write, Greer wanted them to welcome the flares into their hearts. Okay. And then there was a guy that took off.
Just the way you said that. Greer wanted them to welcome the flares into their hearts.
That's right. Well, you gotta have a sense of humor about this stuff.
Yeah.
Otherwise, it'll make you nuts.
Well, in a way, it's sad because it's like you have people out there that have legitimate experiences that really want answers, and you have charlatans out there just trying to make a buck by having people come out and sit in the middle of a desert, or on a beach, looking at flares.
Yeah.
Trying to tell them that it's aliens and stuff like that. It's a big sham. Now, once again, obviously Stephen Greer might have had something that he knew back when, but I mean, I've called him so many times just saying, well, he was briefing heads of state and all that stuff. Like, he might have had a conversation with them after shaking their hand for like a minute. It's not like briefing. In fact, calling him to the White House. You know what I mean?
He claimed that he briefed CIA Director James Woolsey.
Right.
Okay, but that's not exactly true, because what happened was he was arranged to be at the same dinner party as Woolsey and Woolsey's wife, and he cornered Woolsey and talked to him, and that became the quote-unquote briefing to the CIA. You see, and when he started saying that he briefed the CIA, Woolsey wrote him a letter, which I reproduced, put on my site, and I think other people have 1,000 times over, and it said, "You did not in any way brief the CIA. I met you at a dinner party. We didn't talk about anything but pleasantries. So clearly, you need to stop this."
Right.
Okay. And see, that's the thing we're dealing with. And then, Greer is not, in my view, trustable. He's not, doesn't have veracity. He doesn't have any shred of truth. His unacknowledged film that he's coming out with just now.
Oh, I know. And guess who's promoting the crap out of it?
You are.
Secure Team 10.
What a surprise. Because they did all the video for it. No. So his unacknowledged show, that movie there, one of the things that I discovered when I looked at his listing, I took apart his actual announcement, sentence by sentence. And he said, things like, well, we're going to reveal top secret information And on the next line, I said, no, there won't be any top secret information in this. If there was, he would be arrested and he'd be thrown into a rendition camp somewhere until he gave up his sources, because you cannot expose top secret information. It's against the Espionage Act. Ask me how I know. Okay, I've had a clearance since 1995. I've worked for the Navy. I've done a lot of work. And if I expose any classified secrets, whether intentional or by accident, I am subject to the Espionage Act and the full penalties there, and he would be too. And you can't sit there and say, I'm going to give you classified top secret information. He said, I'm going to expose and display classified documents. No, you're not. Not a single classified document is going to be in his dumb movie. Okay, not a single one.
Yeah, they're all going to be ones that maybe like not a lot of people have seen, but they are out there.
Yeah. Yeah.
Just like,
not
was he
all.
the one behind the alien thing last year? Was that him?
Yeah, the Atacama alien.
Yeah,
the Atacama fetus, which he bought from a barkeeper that had it in a glass case over the bar. I mean, come on. You can't make this stuff up.
But then you got to ask what the end game is for a lot of these people. Like, I mean, when you think of people
Money.
like
Greer wants to set himself up as the go-to guy.
Yeah, well, he's searching for more power than anything in the UFO.
Yeah,
field.
I call him the L. Ron Hubbard of he's the L. Ron Hubbard of ufology.
You know what he wants to be? He wants to be the guy that the government calls when contact does happen. Or when something that they need answers, like with anything to do with aliens, he wants to be the government's guy.
Guess what? He's going to be the very last person they ever call.
Right.
They don't want a guy with that kind of a blistering ego in the front line. Oh, no way.
Right.
Right. And not only that, when you talk, and I'm just, I know I sound like I'm coming down hard on the guy, and it's because I'm coming down hard on the guy. What can I say?
Yeah.
Okay,
and rightfully so.
The guy is actually, he's out for money. He wants to, further his cause. He wants to become the go-to person. When you say CE5 on this planet, he wants to be the man you talk to.
Yeah.
And so he's setting up his own little empire. And, you can't blame someone for trying to succeed. I get that.
Mm-hmm.
I can blame someone, though, for trying to scheme their way through it.
But you know what? I find Stephen Greer the exact opposite of David Icke, and where I truly believe that David Icke believes what he's saying. You know what I mean? Because he's that invested in it. I truly believe that David Icke just believes everything that he talks about, even though we can prove a lot of it to be just silliness. But you can tell the difference between the two guys. You can tell that Icke believes what he's saying. You can tell Greer is just out for a different agenda, I guess you could put it.
Well, yeah, I mean, the best thing to do is you look at his last email. The last email that I got from him it read like, come meet the celebrity, Stephen Greer. And this is him writing it, okay?
Right.
He's basically saying, and I'm gonna actually pull it up because I want you to hear this thing, this complete baloney.
Was this the invite to the movie?
No, not that. That's totally different. But stroll the red carpet with Stephen Greer. It's like, excuse me? What is he, a celebrity now? He's elevated himself to celebrity status.
I can't wait.
Okay. Yeah. And what I like is it's funny. Enter to win an exclusive prize package. His comment is on this latest email. Mm-hmm. It says, first prize. Listen to this. Free tuition for a 3-day workshop with Dr. Greer. Dinner with Dr. Greer while at the workshop. Unacknowledged DVD with companion DVDs. Signed unacknowledged book and poster. Because everybody wants a signed poster that has Stephen Greer's name on it. I mean, you see what's going on here?
Yeah,
he's elevating himself to celebrity status because he thinks he deserves it. He thinks he belongs there. And I harken back to what the Native peoples thought. And this. My mother was Native American, and when we harken back to what the Native peoples thought about Stephen Greer when he was talking at the UFO Congress a couple years ago, he shows up with his bodyguard. His bodyguard's armed to the teeth. Mm. The Indians pretty much tackled the guy and said, "I don't think so. Not on our reservation. Get your butt out of here." And so Greer, embarrassingly and sheepishly, had to tell his bodyguard, "Oh yeah, just turn over your weapons to the native guys here, to the Indians, okay?" And just look tough the rest of the time, And I just made it a point every time I walked by the bodyguard to accidentally, bump into him and hit him a couple times. It's like, you know what? You're being your boss is a jerk.
Yeah.
I think he even said that. I walked by him and said, "Your boss is a jerk."
But you know what's crazy about all these people? Like, everybody and the people that actually deserve the attention don't really get it. Like,
Yeah.
I don't know about anybody else, but from my own personal view, I believe Bob Lazar to be genuine.
Bob Lazar, okay, is convincing. Now, whether it's genuine or not, we can't tell. I mean, remember, from a strictly science perspective, there's no data to test what Bob Lazar says. All we have is his memory, and I know from my experience, I've been in MUFON since 1971, 2 years after its inception. So I've been in MUFON forever. And I've seen it go up, I've seen it go down, I've seen it go up, I've seen it go down. I know that every organization has its ups and downs.
Right.
Well, Bob Lazar's stuff, okay, has never been testable. There's no shred of tangible, tactile proof you can lay your hands on that anything he's saying is true. And when 10 humans view a UFO event and report it, they report it 10 different ways. So you have to suspect that Lazar's report to the rest of us is a little bit different from how it actually happened. Now, it could be very accurate in some aspects, but as a human, it can't be perfectly accurate. And you have to go in knowing that. And so you have to say, what's plausible here?
Well, that's true, but what I'm saying is from Bob Lazar, like looking at how he manages himself, how he has treated this whole situation. Like obviously at first, all the attention that it got kind of really got to his head. Not to mention that he had John Lear by his side, egging him on the whole time. But once he realized what was going on, I mean, you'd never seen him at a talk. Never seen him at a convention. You never seen him, even wanting to talk about it.
Well, he did talk to George Knapp at length, remember?
Right. But I'm talking about after.
And I thought it was a good interview.
Yeah, when he came back for like the 20 or whatever it was, year anniversary, I finally talked to him. But, he's not going around doing the circuits. He's not, only thing he's doing is, just like you said in the interview, is he just wants to run his business.
Yeah, a friend of mine out in Arizona is actually very good friends with him. And, I have no doubt that if I go out and spend time with my friend, out there, that I would be able to meet Bob Lazar and talk to him. Thing is, he's okay, I think, with one-on-one. He's just not okay with this whole group thing because there's too many people that have too many harsh opinions. And you got to have a thick skin, and he's got a thick skin, I'm sure. I think my skin is probably as thick as elephant hide after having to deal with some of the people I've had to deal with. Yeah. But it's okay. I don't mind. I mean, I just, as he would say, and as I would say, look, science trumps, speculation.
Yep.
If we have a scientific proof of something, well, then that's it.
What do you think?
You don't like it.
What do you think of Phil Schneider's story?
Yeah, I've always been fascinated with Phil Schneider's story, actually. But I also, again, this is me digging into his background. I find that there were also psychological problems that the guy had. And my question was, how did he get that arm damaged? Did he get damaged doing something ordinary and then conflate it into a fight with aliens in a cavern? Mm-hmm. I mean, is that possible? Nah, as far as I know.
But wouldn't there be some sort of medical records you can get post?
Perhaps.
Because an injury like that,
pretty darn, bad. It would, yeah.
And then, of course, you had Bill Cooper.
Yeah, I talked to Bill many years. I spent a lot of time talking to Bill Cooper,
mm-hmm.
And I always kind of kept him at arm's length.
Yeah.
Because I wanted to, never fall in too far that I couldn't extricate myself. Really. I mean, these people say things, and it's like with Billy Meyer, you got Michael Horn, who's constantly
Oh no.
Out there. And Michael Horn is endlessly harassing, people at MUFON. He's endlessly harassed me. And then he took like silence, my refusal to just answer a question. He took that as proof of his argument. Yeah. And it's like I'd write him and say, by not answering you, it's not proving a damn thing. Okay, I'm not answering you because you're a freaking annoying child. You know,
it's a mouthpiece.
Yeah, I mean, you totally obviate science in order to like be some kind of ambassador. I mean, hello, Billy Meyer's photographs are fake. I can tell it from a million different ways photographically. I've proven it 1,000 different ways, technically and scientifically. They're fake. If you don't want to admit it, I can't help you. All right, but don't you dare say that I think they're not fake, because that's not true. Because I do.
Yeah, he's known to be the ones that are like, well, he hasn't proved this, so obviously everything he says isn't true.
Right. Yep. That's true.
That's the way it is with a lot of. I mean, there's very few genuine UFO people out there anymore, because it's called the UFO bug. Once you get bit by it, you start getting a lot of people wanting to come to conferences and stuff.
Yeah.
That's why I think this New York trip is going to be pretty cool, because we actually get to sit down and talk with one.
Yep.
Just to kind of, it'd be nice to sit back in a chill atmosphere and actually be able just to kind of take it all in before passing any kind of judgment or anything like that. I think it's going to be pretty neat.
Yeah. Yeah. But, I mean, keep in mind that this thing at Pine Bush is a festival.
Mm-hmm.
It's not a conference. So this might be a little different. I mean, I did a talk with Richard Dolan, Peter Robbins, down in New York City a couple of months ago, and that was the New Life Expo. I've never spoken at that kind of conference before. Mm-hmm. That's where everybody can go and say anything they want, and people pretty much believe them. Well,
what I'm talking about is actually at Bill's house.
Oh, at Bill's house?
Yeah, because he's actually coming.
That'll be full of liars. I'm just kidding.
Well, he's actually coming to Bill's.
Yeah.
So, I mean, that's what I was talking about. Sit back, actually chilling.
Oh, wait, who's coming? Who's coming?
I don't know. Am I allowed to say?
Oh, I don't know.
Well, the plan is...
I don't even know if I know.
I believe Travis Walton is coming.
Okay.
The one night.
I know Travis. He's a good guy, yeah.
Yeah, so that's what I mean. We can sit around with him and kind of just sit back and take it all in, and then kind of do stuff based on that. And be not just like I was telling Bill, not to like grill him, like it's some kind of interrogation, but actually have a nice, friendly conversation about it.
He's heard it all.
Yeah.
And the nice thing is he'll probably bring his guitar. He's a phenomenal acoustic guitar player.
Mm-hmm.
Yeah, and I mean, we had a last conference. In the after party, he brought up his guitar, and we always talk. I was sitting with Nick Redfern, and we're talking, and Travis shows up with his guitar, and we're like, "Hey, play a song, let's go." So it was nice. That's the kind of that's enjoyable, especially after a day of talking to people that are and talking about alien life and exoplanets and stuff. Mm-hmm. You just want to relax for a minute,
Yeah. And sometimes, even if you don't believe, sometimes it's good just to hear a good story.
Yeah, it is. It is. And speaking of that, I'm going to have to hop off here soon because I got my oldest son is graduating college later today, as I can see, and it's going to take us about 3 hours to go the 1 hour drive to the college for the graduation because it's going to be really, really hectic. They're going to be graduating 7,000 kids.
Wow.
And there's going to be an awful lot of parents driving an awful lot of cars, and it's going to be an awful lot of global warming going on.
Yeah.
Whole lot of warming going on.
Yeah, I just sent a text. Nasty. I just sent a text to Paul asking him what time he wanted to wrap up.
I think he fell asleep already.
Yeah, well, it looks like he's scanning the moon, so he's still up at some point.
Oh, well, my screen freezes all the time, but then again, we're on Skype too at the same time, and that does cause problems.
I'm surprised. Like my computer's
stealing
been,
bandwidth.
even with all the programs I've running and all the streams and whatnot, and even Skype, I'm still, according to OBS, I'm still only using 21% of my computer,
Right.
which is crazy.
And for the people in the chat, OBS is the software that actually allows you to do the streaming process.
Right.
So that's what this is that we're talking about. And I will be using the same software when I do my stream as well.
Right.
Once again,
Amanda, can you post Mark's channel in the chat there for anybody that wants to subscribe to Marc D'Antonio? Streams are coming up, and you can see him on. Why do I always get these? I can never remember the names of these TV shows. It's NASA Unexplained Files.
Yeah, NASA's Unexplained Files, right? All the seasons, and then What on Earth.
And What on Earth. He's on both.
I just filmed season 5 of What on Earth here in this very office a few weeks ago.
And that'll come out in the fall, correct?
I'm not sure when their season starts, but I can tell you this. I mean, I know that some people in the chat were saying, "Oh, I saw you do the Snails on Pluto story," and that was on NASA's Unexplained Files, but that was actually What on Earth. But they all run together because the shows are fairly close to each other. And it might have been NASA's Unexplained Files as I think about it. I'm
thinking that's why honestly, I get them mixed up because
I don't remember.
Yeah.
Well. And there's another one, another potential show that wants to have me start doing stuff, but I haven't heard back from them yet, and that's okay. I realize that it's not for everybody, and I don't need the attention. I just want to get the science out there, and that's kind of important.
And I will mention that the next time you will hear me and Marc together after our New York trip will be on A.K.A Astronomers. And once again, that'll be after the New York trip. I decided to wait till after that for that stuff. So that's going to be fun.
It will indeed.
Absolutely. But Marc, I am going to let you go so you can go get rested up and be there for your boy tomorrow.
I will. That'll be great, man.
And then I'll eventually wrap up the stream here. But
okay.
Thanks for being on with me once again. It was a last minute thing. We just decided to go for it since it was so nice tonight.
Yeah, well, I didn't have a clear sky. I couldn't stream, and when people come to my site, they'll notice that. And just so people understand, my goal is to try and make the my streams not overlap or take people away from P and K or Bill's streams. We're going to try and do these kinds of things together and in concert with each other. So it'd be kind of a...
Yeah, but I mean, it's okay if you have a clear night, you know what I mean? That's what I'm saying. Like me and Bill stream together all the time, you know what I mean? Where he has a Skywatch and stuff like that. So I mean, it's never a bad thing to actually have two versions of the moon up, from different states, just so you can cross reference, or especially if you're going to do like deep sky stuff, where we might get a night where Bill's got the sky cam going, and then you got some nebulas or something like that, and we got the moon and some planet. It could be. I can take all those streams and pop them into one box. You know what I mean? So, I mean, there's so many possibilities. And once again, we'll talk about that more, there. But you guys definitely have to subscribe to Marc on his channel because, as you saw tonight, you're going to learn a lot of stuff.
Yeah, I'm not like I said, if I don't know something, I'm certainly not going to say that I do.
Right.
So if you guys are interested, that's great. I welcome you over on my channel. I appreciate it. And once I do the streams, it's going to be known as the Sky Tour live stream. Mm-hmm. And the telescope I'm using is a telescope where there won't be a lot of wait time between objects because it's computer controlled.
Just make sure you put all your scope info in your description there, because you have a lot of people asking what you're using.
Yeah, I will. Yeah. I will actually. I'm going to have photos up there for them to see, so they can actually see the observatory and stuff. And I actually want to do. What I actually want to do is have two cameras. I want to have a camera on the scope itself, and then a camera in the observatory, looking at what's going on.
That'd be cool.
And maybe that was a separate camera, but I don't know if I can do a double stream with the bandwidth requirements as necessary. So we'll see.
Right. Yep.
We'll see.
But it's going to be a good time.
It will be, and I want to thank you, Keith, for helping me along and getting the streaming underway, along with Bill. He's been very good at it, and Amanda's been helping me with some ideas. So, you know, it's all part and parcel to getting the information out there and being just getting out there with everything that we can.
It's a big team effort. It's starting to be a bigger team effort, and we're getting a lot of people behind it, and a lot of people that believe in it. And you know what? The viewers, you guys are just the same.
Yeah.
I mean, you guys catch stuff. You guys, like you call it that object you'll know. You guys catch stuff that sometimes we miss. And you're asking the right questions. It actually gets us thinking. So thanks you guys for watching.
No, it's wonderful, and I appreciate everybody's attention, listening to me. And I'll probably never hear the end of the periodic table song.
No, because you're gonna put it on tape, and I'm gonna remix.
Yeah, I mean, actually, you know what? I'm trying to figure out a way to actually sing it live, at the Pine Bush.
Oh, I dare you!
I've been practicing it every day. I've been practicing it because but it's really hard because like there's a section where you have to read very fast: Americium, Curium, Berkelium, Californium, Einsteinium, Fermium, Mendelevium, Nobelium, Lawrencium, Rutherfordium, Dumnium, Seborgium, and you start laughing when you go on like this, Borium. Borium got me because it's like borium, boring, borium, Hassium, then Meritarium, and this goes on and on. Darmstadtium,
and the most important
Rentgenium, Copernicum
of all,
Princium.
Marc D'Antonium.
D'Antonium. Yeah. God, if that was real, I don't know. I'd probably be like highly radioactive and dangerous to all life forms.
Right.
With
an 8-hour shelf life.
With
half-life,
yeah. And that's me.
Yeah, right. All right, Marc.
Cool.
Go get yourself some sleep. Thanks once again for being on. Much appreciated. Right, and I'll see you next week or the week after. So 2 weeks.
All right, man.
All right.
All right, folks. Hey, thanks for your attention, folks. And I really hope you have a good rest of the morning for people that are on the East Coast.
Yeah.
And for the people in England, hey, you're crazy. But that's okay. West Coast is a little easier. All right, guys. Thanks a lot.
Yep. Thanks a lot, Marc.
All right. See you later.
Take care.
Bye.
Now we're jamming. We're going to go back to jamming. And, guys, I'm pretty much going to end the stream. That's what I'm thinking anyway. I'm going to end the stream here. That way Paul can get some sleep. That way we can do the moon stream or the sun stream tomorrow. And it looks like Heidi just showed up 5 hours late. Thanks for showing up, Heidi. Finally. Once again, thanks to everybody in the chat. Everybody that hung around. All the mods. Great job tonight once again. You guys are just kicking some butt. Let me run down this list very quick of people that are still participating in the chat. We got Arnie and Bobo and Sherry and Dang and Dapple and Dave and Deidre and Amanda and Fantasy Guarav. I think that's how you say it. And of course Heidi, who just decided to show up. She should be leaving for New York, I believe, next Saturday? Let's hope. Ian Kendall and Jay Rich, and I'm not even going to attempt that name. It's Leah Gooney, I don't know. LZ, Mighty Mike, Mikey Shim, Norwegian Flavor, Palavika, PTD, Regits. Where do you guys come up with these names, man? Relics and Robert Heron, and my man Rockstar, of course. And Cigar, and Seamus, and Shelley, and the Starseed, and Stephen Smith, and Ted Bronson. The first show, Tommy I, Video Pirate, Weird Guy, and 2 names that are in Chinese or Japanese. I wouldn't even know how to start with those. But thank you all. Solar stream tomorrow, probably around noon. Paul, awesome freaking job tonight. Awesome job figuring out that it wasn't the capture card, that it was actually the computer. So we were able to get back to the old, the better cam tonight. And thanks Marc D'Antonio, of course. So, ladies and gents, I'll let the next song play, and then we'll call it quits for the night. So thanks once again. We will see you tomorrow. Later.